Hello students, am I audible and visible? See if we are live. Yes, are we live? Yes, we are live, isn't it? So many ads, let the ads go. Yes, we are live. Okay, shall we start the class? Okay, so for students who do not know me, hello, hi. Okay, we will start the class. Okay, one second. Yes. Hello students, my name is Gopika and I am a biology educator and I have been doing this for some time now. Okay, so now I am a master teacher in biology. So today we will be doing a very important chapter. I know there are a lot of students in this channel who are NEET aspirants and I thought the best way to help my NEET aspirants at least once in a while is by doing body fluid. That means by doing human physiology. Okay, so today we will be doing one of the very important chapters, that is your body fluid and circulation. That means everything about heart, everything about blood vessels, everything about blood. Okay, so those who are seeing me for the first time, my name is Gopika and I've done post-graduation in zoology and I have been teaching for quite some years now. And I love teaching, so that's why I'm doing this. So yes, I know you'll have a lot of doubts in your head. Why ma'am is coming, or is ma'am going to be here permanently teaching? All these doubts we will clarify later. Okay, so we will start the class. Students, please understand this class. This topic has around 12 to 16 marks weightage in your NEET and also a very important topic from board perspective. Okay, so are you all ready? Can I have a lot of fire emojis in the chat box? Can you put a lot of fire emojis in the chat box? Hello students. So many of you are there. Thank you so much for joining. Okay, we will have an amazing class. I'm telling you, after this class, you will always feel like, oh, I have to attend Gopika ma'am's class. Okay, so if you want to see me, taking everyday classes and very regular, then you have to join us on Vedantu NEET English. That is the main channel where I will be there. Okay, yes. Okay, students. Good morning. I am doing great. Okay, students, shall we start the class? So in this chapter, I will give you an idea about what and all things we will be doing. Okay, what and all things we will be doing. So students, when we talk about this chapter is basically divided into three parts. Okay, so first we will be talking about blood. Okay, then we will be talking about your heart. Very important. All of you need heart. All of you need to know the working of the heart. Right. Then we will be talking about blood vessels. Okay, and then we will be talking about the disorders that can come. Okay, I don't know how many of you read news on a regular basis. All of you know that in Gujarat, when they were having the one kind of a festival, okay, lot of people, around 10 people died with heart attack, and they were all in the age of somewhere between 14 to 25 or say 17 to 25, and it was very shocking because how can such young age, because see students, when the concept comes, how can in such a young age, how can a person have cardiac arrest, how can a person die because of a heart attack? This things keeps coming in our head, right? So for that to know, you should also know the lifestyle that person had, or what kind of genetic disorders, like maybe this has been carried from his parents, right? All these things come. Okay, my name is Gopika Shubham, my name is Gopika. Gopika. Okay? Yes? Okay. Okay, now tell me hi, all of you. Now that you know my name, no, you should tell me hi. Yes. Students, to show your Josh, you should always use the fire emoji. Okay, fire emoji is there, no? You should use that fire emoji to show that, ma'am, yes, I am enjoying the class. Okay, so students, I told you this is what our topic is about today. That means we are going to talk about blood, we are going to talk about blood vessels, we are going to talk about heart, and we are going to talk about disorders. So shall we start? Yes? Okay, students, look here. So when we talk about blood, you should understand that blood is divided into mainly two parts. Okay, blood is divided into mainly two parts. Okay, what are those two parts? First, let me write. Okay. Students, do not ignore this chapter. Chapter might look difficult, but the chapter is actually very, very easy. Okay. I'm just seeing your chats. Okay. Yes, 1 second. Yes, I can see your chats now. Yes, okay. A lot of questions. Okay, a lot of questions. Okay, students, when we talk about blood, all of you should know that blood is actually, when we talk about your connective tissue, right? You have loose connective tissue, you have dense connective tissue, you have specialized connective tissue, or in other words, we can tell fluid connective tissue, right? You can tell fluid connective tissue. So fluid connective tissue is of two types. What are they? Blood and lymph, right? So out of the fluid connective tissue, you will study this in detail when you study your animal tissue portion from your structural organization. As of now, you understand that blood is a type of fluid connective tissue and lymph is also a type of fluid connective tissue, or you can say in other words, specialized connective tissue. Now in blood, when I talk about blood, is this clear to all of you? When I talk about blood, students understand blood is mainly divided into plasma. I think all of you know this, plasma. And what is the other part? Blood corpuscles, right? Blood corpuscles. Can you all see? Right? Yes, blood corpuscles. Now students, plasma. When I talk about plasma, you should understand that plasma in the blood, like if I take the entire blood, okay, now that I have a bottle of water. In the bottle of water, I have mixed say 50 grams of sugar and then I have put some rasna or squash or whatever, okay. Now, when I differentiate it, I will be like, okay, there's 50 grams of sugar, rest is water, right? Same way, if I take blood as a whole component, plasma takes up around 55% of blood. So 55% minus how much will be there? Out of 100, how much will be there? 45%. Correct? Basic maths. 45%. Now, in this 55%, you should understand the plasma is actually the fluid part. It is actually the fluid part of the blood. Now, all of you know that if you have seen this hair transplant ads that keeps popping up on your Instagram and on YouTube, you would have seen that these people take something yellowish, right? They take in a small tube, they take something yellowish, and in that they will add something and they will start injecting everywhere. Have you ever seen that? Have you ever seen that? Okay, they will start injecting something. That is actually plasma, right? That is actually the plasma. So what are they doing? They are trying to modify this person. They're adding some, you know, hormones which actually helps in hair growth by directly taking the plasma. Understood? This is a very effective technique. Okay, this is the fluid part of the blood. Why it is the fluid part of the blood? Not just like that, it's the fluid part of the blood. Because students, this plasma contains around 90 to 92% of water. Pani is there, okay? 90 to 92%, 90 to 92% is water. That is why this is the fluid part. Now you will tell, ma'am, 55% is fluid part. I understood. Now what is the 45%? Students, 45% is actually the blood corpuscles or the semi-solid part. Now the term might look like, oh, very fancy term, but the term is just complicated, but it is simple. You all know this. It contains RBCs, WBCs, and your platelets. All of you have heard this? Yes or no? Easy peasy? Yes, easy. No? So students, RBCs, WBCs and platelets. That's all is your blood corpuscles. There's nothing else. Okay, students, quickly share the link with all your friends and ask them to join if you're enjoying the class, because that much you can do. Come on, that much you can do. Okay, just listen to the class. Let's see. Okay, let's listen to the class. See if you understand or not. Then we will later be like, yes, I understand ma'am's class. No, so quickly share the link with your friends. Okay, so this is clear. So we basically divided blood into a plasma portion which has around 55% and it is the fluid part of the blood. Okay, then why is it the fluid part of the blood? Why do I tell something is fluid, right? That is because it has 90 to 95% of water. Then when I come to the next part, where that is the blood corpuscles, it is around 45% and that contains what? RBC, WBC and platelets. Is this clear? Now students, other than this, even in the plasma, there are a lot of formed elements, there are a lot of proteins and all that, which we will understand in the next slide. Okay, they have formed elements. Okay, they have some kind of minerals. Okay, and mainly students, they have some very important proteins. Clear? Very, very important proteins they have. Clear? Yes? Okay, great. Did you all hit the like button? Did you all smash the like button? Yes or no? Yes, hello, hello. Yes, hit the like button and share the link with your friends. That much you can do to ma'am. That much you can do for ma'am. Yes? Yes, students, let's understand plasma. So, students, see, look here. This is what you see. Okay, so this is the blood. In this, the yellow color portion, right? All of you can see this? Yes. The yellow color portion is the plasma. Who is it? Plasma. Okay, I'll draw it. See, plasma. Now, the red color which you're seeing, like one oval shape or dumbbell shape, okay, that is your RBCs, correct? Then you can see white color cottony structures. White color is who? White blood cells, WBC. Easy to remember. So, WBC is there. Then you can see some, small like here and there you can see some red color portion which actually looks like your COVID virus, but it is not. It is very irregular in shape. That is your plasma. Okay, that is your plasma. So, this is what the whole blood consists of. Okay, so let's write a little about, one second, let me see. Okay, yes. Let's write a little about the plasma. Okay, students, when I talk about plasma, I already gave you an introduction to plasma, that it has around 55, it contains 55% in the blood, and it has around 90 to 92% of water. Yes or no? 90 to 92% of water. Then I told you that it has some kind of minerals and everything. Okay, so students, out of that, okay, minerals are there. This minerals also, which all are there? Calcium, magnesium, okay, HCO3, many others. Now, out of that, they have proteins, like very, very important proteins. Okay, that is the most important thing about plasma when you study. And the first protein they have is albumin. Okay, albumin. Students, when I talk about albumin, no, you should understand. So, plasma has some kind of proteins. Okay, now all these proteins have some kind of job. They're not just coming and sitting like this. Oh, entertainment is happening in the plasma. Let me just sit. No, they have actually come for some job, right? So this albumin, if you have studied excretory system, right? If you have studied excretory products and elimination, you would have heard about something called as BCOP, blood colloidal osmotic pressure. So that is actually a negative force against the glomerular filtrate which is coming. So what it does is, this albumin will not let the water molecules to come in. It will actually block. So this albumin is actually helping for maintaining the osmotic pressure. Easy to remember. Okay. Maintains the osmotic pressure. With the help of which mechanism or with the help of which pressure? BCOP. Okay, BCOP. That means what? Okay, blood colloidal osmotic pressure. Blood colloidal osmotic pressure. Clear? Okay, very important thing. Now, I told you about albumin. Next protein that is there. Okay, next protein that is there is your fibrinogen. Fibrinogen. How many of you know about fibrinogen? You would have studied it in your 8th or 10th. You would have at least heard this word fibrinogen. Students, fibrinogen is actually a protein that helps with blood clotting. Have you heard the word fibrin? Have you heard the word prothrombin? Okay, all these people will end up forming fibrin, which is an insoluble part which will form a mesh. So imagine, let's take one person's name. Aman is there in our class. Okay, imagine Aman fell down. Okay, Aman fell down and he made a wound on his knee or on his hand or somewhere. Now, first starting, Aman is noticing that there is a lot of blood loss. Okay, because the wound was very severe, Aman lost a lot of blood. Now, Aman is thinking after some time, the blood has actually stopped. Like he's able to control. It's not like it's just, flowing excessively. Something has happened in the body. Now, what is that something? Students, imagine this is my hand. Okay, this is my hand and this is a mesh. Think this is a mesh. Okay, can you see my hand? Yes. Okay, this is my mesh. Now, blood was coming. All the blood was losing out like this at the first. Now, then platelets will get a signal. that then there is a wound that has happened. Aman has actually fell down and he hurted himself. Now we have to protect from we should avoid maximum blood loss. So this fibrinogen or this fibrin will form a mesh and make sure that this RBC does not go out anymore. It will make a mesh. I'll show you the mesh. It will make a mesh and block all the RBCs from losing out. That's why after a few days you will see a brown color layer on it. Then you will see that will fall off and then the skin will be there. A very whitish color layer will be there. So that is actually our body doing. Now who is doing that? Fibrinogen is also helping in that. So fibrinogen is actually for blood clotting. It's actually going to help for blood clotting. Clear? Is this clear? Then the last protein which is there in the plasma, okay, last protein which is there in the plasma is globulin. Okay, what is it? Globulin. Okay, students, when we, I don't know how many of you there, when we did your human health and diseases, we heard about immunoglobulins, IgA, IgG, IgE. All of these people are doing one kind of mechanism, right? That immunoglobulin comes from where? Globulin. So globulin is actually has alpha, beta and gamma. Okay, 3 types of that, alpha, beta and gamma. All of them are for defense mechanism. Okay, some of them are carrier proteins also, defense mechanism. Is this clear? Is this clear to all of you? Let me know quickly. Yes, clear? Okay, fine. So students, albumin, fibrinogen, globulin. This is the proteins that are there. Okay. Is it not clear on the camera? Students, is the camera clear? 1 second. Let me see. Okay, it's clear. Okay. I think I'll check the camera once. 1 minute. Yes, it's clear. Right? It's clear. Okay. Focus that one. Yes. Okay, students. So this much clear? Fine. Let's go to the next part. So plasma is clear. We did plasma. Okay. There are a lot of minerals in it. There are a lot of proteins in it. We learned about all the proteins, right? We learned about all the proteins. Okay. Yes, it's clear. Okay. Thank you. Yes, yes. Okay. Now students, understand plasma without the clotting factor. Plasma without the clotting factor is called as serum. Okay. I'll write it in the first page actually. Here I'll write plasma without, let's take a nice color. Yes. So I'm writing it here. Plasma without clotting factor. Or let's write clotting protein. Okay, it's called serum. Or if you know hair serum, and we use hair serum and all. So that means what? Absence of fibrinogen will be called as serum. Okay, plasma without fibrinogen is called as serum. Okay, clear? I'm writing it here. No fibrinogen. Okay, now let's understand the first. So we understood that plasma is there. Next topic is what? Blood corpuscles, right? Blood corpuscles. And who is the hero in blood corpuscles? Your RBC. Okay, so blood corpuscles as RBC, WBC and platelets. In that, RBC is the most abundant person. Okay, RBC is the most abundant. Most abundant. Now, most abundant means what, students? Yes? Most abundant means what? That means more in number. Simple, more in number. So, what's the number? It is present around 5 to 5.5 million. Okay, 5.5 million per mm cube of blood. Clear? So, in a person's body, RBC is going to be around 5 to 5.5 million per mm cube of blood. Okay, clear or not? Is this clear? Yes, clear. Now, next question comes, where is this RBC actually formed? Okay, it is formed in the bone marrow. I think all of you would have studied this in your smaller classes. Bone marrow. Okay, so students, formation of this RBC has a name. So where is it formed? In the bone marrow. Now, what is the process by which this RBC is formed? Erythropoiesis. Okay, erythropoiesis is the process by which RBC is actually formed. Okay, clear or not? This is clear. So students, erythropoiesis, 1 minute. Yes, ad is coming. Okay, erythropoiesis is actually the process by which RBCs are formed, and erythropoiesis is happening because of with the help of a protein called erythropoietin, with a protein called as erythropoietin. So I'll write here in the protein, okay, erythropoietin, which is actually synthesized by a cell called as JG cells. Now again, students, this JG cells also comes in the excretory system. There is afferent arterioles. All of you remember, afferent arterioles will get modified. Afferent arterioles, some cells will get modified to form JG cells. That JG cells, or your juxtaglomerular cells, will form this erythropoietin protein, which actually helps in erythropoiesis. Okay, so RBC formation happens with the help of erythropoiesis, which is because of a protein called erythropoietin, which is formed by the JG cells. Clear or not? Simple? Simple? Yes? Simple, dimple? What is happening? Yes, okay. Fine. So students, clear? Now, this RBCs, okay, they're actually devoid of nucleus. They are devoid of nucleus. So I can say it is enucleate. Okay, I can say it is enucleate. Okay, enucleate I can say. Sorry. So they are devoid of nucleus. They are devoid of nucleus. So we call it enucleate. Now students, understand. RBC is normally, when we learn it, we say it is dumbbell shaped. Have you all heard this? It is actually dumbbell shaped, like this, no? Like this. Okay, it is dumbbell shaped. And in some organisms like camel, they are circular in shape. Okay, usually it is dumbbell shaped. In some organisms, they are circular in shape. Okay, clear or not? This is the shape of RBCs. So we have dumbbell shaped. In some places, maybe you will also see biconcave, right? Biconcave word. So that word also is important. Biconcave or dumbbell shape, and in some it is circular in shape. Yes. Now RBC can be more or less. That means in a person's body, is it necessary that always RBC has to be more? Okay, RBC has to be more. Students, there's no problem with the line, no? Yeah, okay. It's not necessary that RBC always has to be more. 1 second. Yeah. What is happening? Here it's not loading. Is it? There's no problem, I believe. Yes. Okay, fine. So students, circular, biconcave, is that clear? Now I told you that not necessary that every person should have the same amount of blood. That means someone can have a deficiency, someone can have an increase. So if it is deficiency, that means RBC is deficient. Okay, so if RBC is, there is a deficiency, then we call that condition as erythro. Okay, yes, erythropenia, erythrocytopenia. Okay, you can say erythropenia or you can say erythrocytopenia. Now, if there is an increase, okay, not every time the blood has to be like deficient. Like some people can also have an increase. That means in the bone marrow, blood is forming more, right? In the bone marrow, the blood is forming more. So that time, what do you call it? Polycythemia. Polycythemia. Yes. Students, if you understand this chapter, this is one of the most beautiful chapters. So try to understand. Okay. Yes. Students, now all of us know that RBC has something called as hemoglobin, right? All of you know that it has something called as hemoglobin. So students, this hemoglobin is actually not, not just providing the color, not just having the iron content. It is actually a respiratory pigment. It is actually a respiratory pigment. That means what? It is actually helping in the exchange of gases. It is not just there. It is actually helping in the that means exchange of gases. Clear or not? Okay. Yes. Good job. So hemoglobin is a respiratory pigment which is actually providing the color to the RBC. It also has some iron content and it is also a respiratory pigment. That means helping for exchange of gases. Now, a healthy person. Okay, imagine a healthy person. That means like who does not have anemia or who does not have erythrocytopenia or polycythemia. Imagine that person will have a normal hemoglobin count of 12 to 16 grams. Okay, they will have 12 to 16 GMS. Okay, that is how much hemoglobin a healthy person, okay, a healthy person will have. Okay, healthy person will have. Okay, this much clear. This is all about your RBC. Did we miss anything? Yes, we have one more concept which is very, very important. Okay, that is, students, what is the lifespan of RBC? Do anyone in the class know the lifespan of RBC? Yes or no? Do anyone in the class know the lifespan of RBC? The lifespan of RBC, okay, is around 120 days. 120 days. That means how long it will be there? 120 days. Now 120 days RBC, where will it go and, khatam, right? Where will it go and die? It will go to someone called as the spleen. Okay, spleen, which is called the graveyard of RBC. Students, who is called the graveyard of RBC? Spleen is called the graveyard of RBC. So RBC have 120 days lifespan. It will go and the RBC will be completely destroyed in the spleen, which is called the graveyard of RBC. Very good. 120 days. A boy from Kashmir. Very good. 120 days. Good job. Okay, clear? This much clear, students? RBC completely clear. Let's do a quick revision. Okay, look here. RBC, students. So it is one of the blood corpuscles. Okay, and it is the most abundant. That means if you see the blood as an entire thing, if you check the blood corpuscles, RBC is the most. It is around 41%. Out of the 45%, 41% is RBCs, 4% is WBC plus platelets. Okay, so it is the most abundant and it is present how much? 5 to 5.5 million. Yes. Okay, it is around 5 to 5.5 million and it is formed where? It is formed in the bone marrow. Okay, it is formed in the bone marrow and this process is called erythropoiesis and it is happening with the help of a protein called erythropoietin, which is actually formed in the JG cells in the afferent arterioles of the, you will study more about that in the excretion chapter. Okay, yes. They are devoid of nucleus. That means they do not have nucleus. So I can call it enucleate. Okay. And RBC can be biconcave in shape or dumbbell shaped. Okay. And in some organisms like camel, they are circular in shape. That is kind of like a adaptation. Okay. And now look here, students. RBC does not always have to be 5 to 5.5 million. For some people, it can be less. For some people, it can be more. That means a big change is there. It's not like, okay, 5, like instead of 5.5, I have 5.2. That is not a very this difference. Okay, that means 5 is also fine, 5.5 is also fine. Between this any range, it is fine. Okay, so deficiency is called erythrocytopenia and increase is called polycythemia. Okay. Now, there is a factor, there is one person, very important person in the RBC, which is called as hemoglobin. Okay. That hemoglobin is actually the respiratory pigment. That means it will help in the exchange of gases, and a healthy person will have somewhere between 12 to 16 hemoglobins. Okay. Now, RBC has a lifespan of 120 days, and where will it go and like completely get vanished? It will be in the spleen, which is called the graveyard of RBC. Clear or not? Clear or not? Can we go to WBC? Yes, can we go to WBC? Yes or no? Tell me in the chat box. All of you, WBC. Right? Leukocytes. No, WBC is called the leukocytes. Yes. Okay. So students, WBC is also known as leukocyte. K or C you can use. Okay, let's also write for all of them. Right? Here let's write erythrocytes. I'm sure all of you know this, but still we will write it. Erythrocytes, WBC is called leukocytes, and platelets are called thrombocytes. Okay, thrombocytes. Okay, we have written everything. Now VEC. Now leukocytes, students. Leukocytes are not as abundant as your RBCs, but it is there. It is there. Okay, how much? 6,000. Okay, it is not that abundant. It is around 6,000 to 8,000. Okay, per mm cube of blood. Per mm cube of blood. Always follow per mm cube value or unit. That is more easier. Okay. Yes. Fine, students. Now leukocytes. Okay. Now when you talk about leukocytes, the normal count is around 6,000 to 8,000 per mm cube. Okay. Yes. Yes. We will do question practice. Okay. Yes. We will do question practice. Okay. So students, it is colorless. Now it is colorless. Okay. Colorless because of what? Who is giving color to RBC? Hemoglobin. Here who is there? Absence of hemoglobin. Absence of hemoglobin is the reason why these people don't have any color. Okay, they are colorless. They are colorless. Okay. Yes. Now students, now we understood they are colorless. Now when we talk about WBC, they're actually mainly for defense mechanism, right? They are the people who protect our body. They are the people who protect our body, right? All of you know this, yes or no? Even though they are less in number, they are doing the job. Okay, and students, they are nucleated. Okay, they are nucleated. That means RBC was enucleated. That means did not have a devoid of nucleus. Here they are nucleated. Now understand, WBC also can be more or less. Okay, WBC also can be more or less. So if it is a deficiency, and if there is an increase, okay, students, if there is a deficiency, that means we call it, anyone knows the name? Anyone knows the name? Leukopenia. So whenever the word penia comes, deficiency. Okay, leukopenia. Leukopenia. Increase. Can you think of any of them? Yes, you can follow me on Biology by Gopika, my Telegram channel, and you can also join on Vedantu NEET English, where you can ask us the doubts. Okay, entire PCB doubts you can ask. Yes? Okay. Students, a boy from Kashmir, I hope you got the ID, dear. Yes. Students, so what is it? Leukocytosis. Leukocytosis. Okay, that is increase in WBC. Decrease leukopenia. So whenever the word penia comes, you always think about deficiency. Whenever increase comes, it will be leukocytosis. Clear? Okay. Now students, WBC is not such a like a power person. He has many army. He's like the hero. He has many army. So WBCs are actually mainly of two types. Under two types, you will study 5 types. Okay. Was it like a tongue twister? Okay, so students, WBC is mainly of two types: granulocytes and agranulocytes. You can share this video to all the friends who are preparing, like who have backlogs in their 11th or who is right now in 11th. You can share this video to your friends, okay? Because all this is NCERT. Every single word is NCERT. I am just writing the notes for you people, okay? So students, granulocytes means they have granules, right? So let's draw one very diagram just to understand, okay? Okay, this is the we're just going to draw it. Okay, this is a neutrophil. They have granules. Okay, these are granules. Now, agranulocytes means what? They do not have granules. They do not have granules. Right? No granules. They just have normal, whatever is there in the cell will be there. Okay. Okay, got it? So that is agranulocyte. This is granulocytes. Now granulocytes also can be further divided. Okay, that means whoever has granules will be put together. Whoever does not have granules will be put together. So under agranulocytes, students, 3 are there. Who are there? 3 are there. And under agranulocytes, 2 are. So under granulocytes, 3 are there. Under agranulocytes, 2 are there. So under granulocytes, you have neutrophils. We will study about this. Neutrophils, basophils, and eosinophils. Okay, eosinophils. Now, in agranulocytes, you have monocytes and lymphocytes. Okay, clear? Monocytes and lymphocytes. Okay, this is the category. Yes. Did you all like the session? Come on, like the session, all of you. Yes. Students, so understood. Granulocytes are neutrophils, basophils, eosinophils, and agranulocytes are monocytes and lymphocytes. So because of the presence and absence of granules, they have been separated. They have been separated. Okay. Clear? Easy? Okay. Yes. Fine. Granulocytes, students, understand. Now let's write it here. Yes, let's write the separation. Now, when you talk about granulocytes, I already told you neutrophils are there. Okay, basophils and eosinophils. Yes. So generally, granulocytes be in the body for around inside the blood vessels for 4 to 8 hours. But at a point where they understood that there is an infection in the tissue, they will, if they go to the tissues, right, it will take around 4 to 5 days. That's the lifespan. So if it is in the blood vessel, 4 to 8 hours. If it is in the tissue, it will be 4 to 5 days. Okay. So neutrophil, students, they are multi-lobed. Okay. Now, like one earphones I'll be drawing, they are multi-lobed. Can you see many lobes? They are multi-lobed. Okay. When we talk about basophils, they have an S-shaped lobe. Okay. They have a S-shaped lobe. Okay. And when we talk about eosinophils, they have a headphone type of a lobe. Doesn't it look like a headphones? Okay. They have a headphone shaped lobe. Now, understand, neutrophils are the highest in number. That means if I take the entire WBC, neutrophils are the highest in number. That is where it is around 60 to 65%. That is how much neutrophils are there. Okay. Now, students, all of you look the name: neutrophils, basophils, eosinophils. Something to do with neutral, acid, base. Eosinophils are also acidophils. So can anyone tell me neutrophils means what? So if I stain it with something, is it going to behave neutrally, or is it going to show acidic medium or basic medium? What is it going to show, students? Is it going to be neutral? Neutral? Yes? Is it going to be neutral, basic, or acidic? Come on, tell me, all of you. All of you tell me. It can be stained with both acid and basic dyes, right? It can be stained with both acid and base. Got it? Clear? And students, understand, neutrophils are actually the first level of defense. That means imagine something entered, some foreign particle entered my body. First person who's going to fight is going to be a neutrophils. So it is phagocytic in nature. Okay, phagocytic in nature, and it is the first line of defense. Okay, it is the first line of defense. So first person who will go and fight, right? You and your siblings, who fights first? Younger ones will fight or elder ones will fight? Mostly the younger ones will fight. So that becomes the first, right? Yes, always ready for a fight. Now, basophils are S-shaped. They're S-shaped lobes, and they are around 0.5 to 1%. That's all. That's all these people are there. 0 to 5. 0.5 to 1%. That's all they have. Now, from the name itself, we understand we can stain them with the help of basic dyes. Yes, we can stain them with the help of basic dyes. Now, what is the main job of these people? They actually causes inflammation. Since inflammation is a reaction, all of you know this, it's a response, right? It's a response to make us understand that, okay, you're allergic to something or something is happening, right? So they actually causes inflammation. Clear or not? Now, understand this basophils also secrete some some enzymes that are, first one they secrete is heparin, which is actually an anticoagulant. Okay, if you have understood dialysis, you will see that they give heparin and then they give anti-heparin while taking the blood, and adding the, after purification of the blood, when they add it back also, they had this heparin, which is an anticoagulant. Okay, then we have histamine. Students, histamine is actually a vasodilator. That means when vasodilation happens, that means whenever an allergy happens, there's mast cells, right? Those cells will get an information that there is a foreign particle. I am dust allergic, so there is a dust that has entered my body. Immediately the mast cells will be like, I have to release histamine. So when I release histamine, what is going to happen? It is actually a vasodilator. So it will dilate the blood vessels and allow more blood to flow through them. That is the reason why you start seeing that you're red, your nose starts getting red, your cheeks start getting red, your eyes starts getting red. So you can see that more blood vessels are moving, more blood is moving. Okay, so the entire redness is because of this histamine, which is a vasodilator. Okay, clear or not? Then we have last one is serotonin. Serotonin, which is a vasoconstrictor. Okay, vasoconstrictor. Now, eosinophils or acidophils. From the name itself, it is acid stains. Okay. Now, what is the number? It is around 2 to 3%. 2 to 3%. And for a very, very important thing. Okay, very, very important thing. This is the one that actually suppresses an allergy. Okay, this is the one that actually suppresses the allergy. So imagine an allergen is coming. Eosinophils will be the first one to suppress the allergy. Clear or not? Okay. Yes. Fine. Okay. This much is all about your granulocytes. Okay, this is all about your granulocytes. Yes. Okay, granulocytes. Students, you can look here. I've just put a flow chart. Leukocytes, granulocytes, agranulocytes. Granulocytes are divided into eosinophils, basophils, and neutrophils. And leukocytes again divided into agranulocytes, where you have two people. That is your monocyte, and lymphocyte. Okay, lymphocyte. Then you can see the number, the least one. This is the least. This is the least one among the granulocytes, which is around 0.5 to 1%. Okay, yes, next one. Now, platelets. So, students, when we talk about platelets, all of us think about one thing, clotting. Right? Whenever you think about platelets, what do you think about it? It is something to do with clotting and all that. But before that, you need to understand, students, these platelets are actually not a true cell. Not a true cell. You'll be like, ma'am, what are you saying? It's not a true cell. Yes, students, true. So imagine this is a megakaryocyte. This is a megakaryocyte. This megakaryocyte will undergo fragmentation. That means small fragments will be formed. Okay, fragmentation will happen, fragmentation will happen, fragmentation will happen. Okay, imagine complete breakdown is going to happen. They are going to form fragments. They are going to form fragments, right? Yes, very good. So they are going to form fragments or produced by a megakaryocyte, which are actually the cells in the bone marrow. They are actually special cells in the bone marrow. This is their location. Special cells in the bone marrow, which actually gets completely broken down. That means fragmentation will happen, and that fragments are actually the platelets. Clear or not? So you have megakaryocytes which will completely undergo fragmentation, and they will form fragments which are actually the formation of the platelets. Okay, they form the platelets. Okay, now that this much is understood, let's also understand, students, platelets are also called thrombocytes. I already mentioned. What is the count? Okay, their normal count is somewhere between 1.5 lakhs to, I think you can say 3. In some places you would see 3.5. So you can say 3.5 lakhs. Okay, that is how much platelets has to be there. Now, how do a person have dengue? A person has dengue when their platelets count drop to 10,000, 20,000, 30,000, which is like very, very low, right? This has to be in lakhs. From lakhs, it drops to thousands. Now, the person's defense mechanism, the entire clotting, all the functions that is being done by the platelets will come to a big, big question mark. Okay, to a big question mark. Okay, now if this is clear, okay, if this is clear, yes, okay. Students, one thing I missed to tell is here about your monocyte and lymphocytes. Monocyte actually has the it is actually the largest cell. Okay, this is actually the largest. And in lymphocytes, 2 cells are there, B cells and T cells. Again, you'll study this in human health and diseases. B cells and T cells. Okay, monocyte is the largest cell, but neutrophil is largest in number. Larger in number. Okay, and this has a kidney-shaped lobes. Okay, kidney-shaped lobes. Lymphocytes have circular. Okay, circular. Okay, got it? That's the only thing I forgot to mention. And lymphocytes also has large nucleus. Okay, large nucleus. Yes. Now we will continue. Okay, students, this much clear? Okay, yes. Now what is going to happen? Again, deficiency is going to be there. Increase is going to be there. Okay, so thrombocytopenia. Whenever penia word comes, it's deficiency, right? So whenever platelets are deficient, and same way platelets increase. So students, deficiency means, again, what does I say? Thrombocytopenia. Okay, and increase means what? Thrombocytosis. Remember, thrombocytosis. Okay, these are the words to remember. Done, dusted. Did you all write notes? Okay, now students, I told you, the moment you think about platelets, whom are you going to think about? You're going to think about clotting, right? So, platelets form the clotting factor, okay? Platelets actually form the clotting factor. Clear or not? Clear or not? Yes, platelets form the clotting factor. Okay, that is what this is. Okay, it actually forms the 3rd and 13th factor. Okay, so it has a lifespan, students. Oh, yes, it has a lifespan of 7 to 8 days. That's all. It has a lifespan of 7 to 8 days. Who has a lifespan? Platelets have a lifespan of only 7 to 8 days. RBCs had 120 days, right? And the graveyard of RBC is spleen. Okay. Now platelets have 7 to 8 days. That's all is the lifespan of platelets. Okay. Why do we, the moment we think about platelets, why do we think about clotting? Is because platelets form the clotting factor. Done? Dusted? Okay. Yes. Okay, done. Fine. Now, students, we have to understand clotting, which let me see. Yes, I think we'll write about coagulation here. Okay, platelets done. Okay, now what will happen if the platelets number decrease? I told you platelets can decrease. So imagine platelets number decrease. What is going to happen? Blood clotting will happen. Blood clotting will decrease. That means excessive loss of blood will happen, right? Excessive loss of blood. Because imagine, students, clotting factorly is not there. Clotting factorly is not there. Then how will, the mesh formation happen? I told you, if person is going to fall, the RBC is going, right? Now, what is going to happen? Mesh formation will happen. It will not allow RBC to go, right? That will not happen. If that is not going to happen, then excessive loss of blood will happen. Isn't this understood? Yes or no? Okay? Yes. Now, students, look here. Imagine I centrifuged. What did I do? I centrifuged the entire blood. I centrifuged the entire blood. Now, what do you see here? You see a yellow color portion which is called a plasma. Now, all my students know it is a yellowish fluid. It is the fluid part of the blood. It is around 55%. Yes. Now, after that, you will see a small portion where you will see the WBCs and the platelets. And then the larger portion will be your RBC, which is around 41%. 4% will be this. 55% will be this. 100% did we make? Right. This is the different levels of the blood. This is only when I centrifuge it. Now, what is a centrifuge? That means a tube is there. We continuously go through some RPM, and after some time they will start settling. They will start settling according to their gradients. Okay. They will settle according to their gradients or density. Okay. Depending on gradients or density, they will start settling. That is called as your centrifugation tube. Okay. Yes. Fine. That is clear. Okay. Now, students, blood grouping. Okay. Very, very important. Very, very interesting concept. Now, all of you look here. Students, what is your blood group? Put it in the chat box. What are your blood groups? Are you A, B, C? What are your blood groups? Students, look here. We have blood group A, blood group B, blood group AB, and blood group O. Now, blood grouping in your textbook, if you notice, blood grouping are of many types, but as of now, we are going to study about your ABO grouping. ABO blood grouping. Okay, ABO blood grouping. Now, ABO blood grouping means there is an antigen, there is an antibody. If you notice here, can you see antibodies in the plasma, antigens in the red blood cells? So, understand, students, there is an antigen. Let's write it with another color. There is an antigen and then there is an antibody. Now, this antigen is actually something to create that response, to make that response. Okay. Sorry. Air got stuck in windpipe. Yes. Yes. Okay. Students, look here. Antigen and antibody. Now, antigen is there, antibody is there. Antigen is actually a type of glycoprotein. What is it? It is a type of glycoprotein. Got it? A type of glycoprotein. Now, where is antigen going to be present? It is going to be present on the surface. Where is it going to be present? Very important, students. Many MCQs can come from this. Actually, 2019 there was an MCQ where they twisted the question. They gave antigen in the plasma, antibody in the surface. Students blindly went and answered antigen in the plasma. Antigen is in the surface. So imagine this is the blood cell. Now this is the surface. Okay, blood cell is there. That is the surface. So it is present on the surface, right? Got it? Now this is the blood group A. Here is where your antigen will be present. Okay. Now antibody. What is antibody? Antibody is a type of protein, right? We all know this, right? It is a type of protein. And this protein is present in the plasma. This should be very, very important. Who is in the surface? Who is in the plasma? Who is in the surface? Who is in the plasma? Two types of antibodies are there. Antibody A, antibody B. Now let's see which is your blood group. Did you all put it in the chat box? So it's group A. Okay, blood group A. They will have anti-B. Correct? Antigen has to be opposite, right? Antigen and antibody has to be opposite with each other. So they have blood group A has anti-B. Okay, and what antigen will they have? Antigen A they will have. Okay, same antigen. That means whichever blood group is the same antigen, antibody will be different. Okay, antibody B. Now blood group B will have anti-A. Simple. Blood group B will have anti-A. What antigen will it have? Same antigen B will be there. Okay. Now antigen is actually to create that response. Okay. Now blood group AB. Blood group AB, students, I cannot put anti-A nor I can put anti-B because they both will fight. Jagda ho jayega, no? So they will fight. So that's why I have not put anything. Okay. AB will have no antibodies at all. No antibodies, none. Okay. And then they will have what kind of antigen? They will have both A and B. Clear or not? Now O. Look at O. They will have both the antigens, but they will have no antibodies. Sorry, they will have both the antibodies and they'll have no antigen. Okay. So AB and this is ulta. These people have no antigen, but they have they have no antibody, they have both the antigen. Here they have both the antigen, they don't have antibody. Okay, this you have to write. Okay, this you have to write. Okay. Please make a note. You already have a box there in your textbook. That's why that's all. You don't have to know a lot about it, but you should understand one thing. Students, look here. Let's write it here on the side. A is there. Okay, let's write O. Okay, who is the universal donor? A is there. AB is there. Okay, this 4 people are there. Now, O can give blood to A, to AB and to B. O can give blood to A, AB and B. Right? Because of absence of, see what is absent here? Look here. What is absent? Antigen is absent. Because of this absent, O can give blood to all the 3 people. Same way AB, it can take blood from everyone. Why? Because it does not have any antibody. No reaction will happen. Okay. Now students, look here. O is giving blood to everyone. AB can take blood from A as well as B. AB can take blood from all the 3 people. O, A and B. So who does AB become? AB becomes universal recipient. Yes or no? Universal recipient. O becomes universal donor. O becomes universal donor. Okay. Thank you, Tanveer. Thank you so much. Okay, students, look here. AB is the universal recipient. That means it can take from anyone. It does not have any problem. A is giving, B is giving, O is also giving. I am ready to take it from anyone. Okay, same way O. O is a giver. O is like a very power Mother Teresa person. He'll give everything what he has. Everything what he has. So O is giving to A also, AB also, B also. He's giving everywhere, right? Right? Mother Teresa also is very sweet. She used to give help everyone, right? Same way. O is giving for everyone. Okay. So O becomes universal donor. AB becomes universal recipient. Now students, we studied ABO blood grouping. Now you have to study something called as RH grouping or rhesus grouping. That means this rhesus word came from the monkey. Rhesus monkey. So they took the same word. RH grouping. Okay. RH grouping. So understand, RH grouping does not have much of a significance, okay, but it actually denotes if you are A positive, B positive, okay, positive, negative, right? That is denoted by your RH. That is denoted by your RH. Any doubts on this? Any doubts on this? Yes or no? Okay. Okay, fine. No doubts. Students, look here. This is a blood group. So say A is the blood group. This will have RH group. If it has RH group, that means what this becomes? This becomes A positive. A positive. If RH group is absent, so imagine B. RH group is not there. This becomes B negative. Clear? B negative. Yes or no? Okay, clear? Yes. Okay, done. Okay, now all of you in the chat box type what antigen you have, what antibody you have. All of you type in the chat box what antigen you have, what antibody you have, and do you have RH factor or you do not have RH factor. Quickly type it in the chat box. Okay. So students, presence of RH, right, indicates what? Indicates positive. Absence indicates negative. Absence indicates negative. Okay. Absence indicates negative. And where it will be present? On the surface. Okay. It will be present on the surface. Clear or not? It is present on the surface. That's all. Easy. RH. Easy. Right. Okay. Okay, done. Are we ready? Can we do coagulation or clotting of blood? Other word is clotting of blood. Yes? Fine. We can do clotting of blood. Students, I told you your 3 and 13. Okay, 3 and 13 factors. So understand, there is 1 to 13 factors. How many factors are there? 1 to 13. In Roman numbers. Okay, 1 to 13. This many factors are there for coagulation of blood or clotting of blood. Out of this, platelets is going to secrete, or platelets is helping in the formation. Okay. Platelets is actually helping in the formation of your 3rd and 13th factor. Clear or not? So, platelets is helping in the formation of your 3rd and 13th factor. That is why whenever we think about platelets, we think about coagulation, we think about clotting. What if platelets are not there? Clotting will not happen. Excess blood will be given out. So, students, platelets, 3 and 13. Easy to remember 3, 13. 3, 13. Okay. But it has to be written in Roman numbers. Okay. So, 3 and 13 factor is secreted by the platelets. Now, okay, wait, yes, okay. Now, students, we have to know the flow. Okay, we have to know the flow of how clotting will happen. Okay, now understand, I told you 3 and 13th factor secreted by the platelets. Now, the rest of them, right? The rest will be secreted in the liver. Rest will be secreted by the liver. Rest by the liver. Now students, imagine injury happened, right? We have to go step by step. Injury will happen, thromboplastin will be released, then thrombokinase will be released, right? Thrombokinase will activate prothrombin. So it is a procedure. Let's see. So an injury happened. Okay, an injury happened. Clear? All of you are there with me? Yes. Yes, okay. Okay, students, one injury happened. Okay, now I can see all of you. One injury happened. Now that injury, when the injury happened, first thing to be released is your thromboblastin. What will be released? Thromboplastin. Right? Thromboplastin will be released. Got it, all of you? Now this thromboplastin will activate who? Thrombokinase. Will activate who? Thrombokinase. Now thrombokinase will go and activate prothrombin. Prothrombin. Now this prothrombin will go and activate thrombin. Students, this is like waterfall. From the top, the water will flow. One step, one step, one step, one step. Correct? Top has to activate, like from the water from the top has to move down, 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 down. It is a continuous, right? It is also called as cascade mechanism or a cascade reaction. That means one after the other, one after the other, one after the other. If you see here, injury happened or a trauma happened. From there, thromboplastin got activated. Thromboplastin will activate thrombokinase. Thrombokinase will activate prothrombin. Prothrombin will activate thrombin. Now this thrombin will form the very important protein. Now all of you tell me, where did we see this protein before? Where did we see this protein before? We saw this protein in plasma, fibrinogen. So students, fibrinogen is actually a soluble protein. So we do not want a soluble protein. We want an insoluble mixture. Okay, this is the soluble person. We will make it an insoluble person. So we will form something insoluble called as fibrin. Okay, we will make something called as insoluble called as fibrin. Yes or no? Clear? Okay, fibrin. Now this fibrin is actually the insoluble part. This will allow the formation of a mesh. Okay, this will actually help in the formation of mesh. Now students, don't you think if so many activations are happening, right, so many activations are happening, don't you think someone should be there, some mineral should be there, some ion should be there? Yes or no? Someone should be there, right? So look here, when an injury happens, thromboplastin will be activated. Now for that we need calcium. We need calcium. Okay, here we need calcium, here also we need calcium. In every step you need calcium for the activation to happen. Clear or not? In every single step you need to have calcium for activation to happen. Clear or not? Easy peasy. Easy? Yes. Okay, done. Okay, this is what is coagulation of blood. Okay, now students, what is this fibrin going to do? I told you, fibrin is actually going to form a mesh. Right? It is going to form a mesh. Mesh formation. Okay, to actually avoid coagulation. That means to actually coagulation to happen. Now what is going to happen? Imagine this mesh is formed. This RBCs will come and stuck here like this. Okay, RBCs will come and get stuck here. Okay, this is what is coagulation of blood. Easy? Okay, so what do we need the most? We need calcium. We need calcium at every single step. Okay, clear or not? We need calcium at every single step. Students, now understand. Now what happens in blood banks? right? In if you know that when dengue happens or dengue happens, no, a person will go like if the platelets count has reduced very much, they'll tell you need to bring platelets from outside. Now we know that these platelets are going to coagulate, right? They are going to become like one solid mess. Now can I inject that into a person? I cannot. So what I'm going to do, sodium oxalate will be added. Okay, sodium oxalate will be added in blood banks to actually avoid or to remove, in other words you can say remove calcium. Okay, remove calcium so that coagulation does not happen. I told you in every step we need calcium. If calcium is not there, how will all this happen, right? So blood bank to remove calcium to avoid, so no coagulation or clotting happens. Okay, no clotting happens. Clear? Easy? Oh, fine. Let's go to the next one. So this is what I told you. Have you seen one dashing another, dashing another, another? So this type is called as cascade reaction. Cascade reaction. That means what? One after the other. So it's the same like waterfall, right? One after the other, right? It keeps going. So it is like a waterfall. So this is called as cascade reaction. What is a cascade reaction? That means clotting of blood is a cascade reaction where one after the other, it continues. If one is also missing, the next one will not happen. Clear? Okay, done. Fine. Students, now we have understood platelets. Now we have one more topic, okay, called as erythroblastosis fetalis. Now look here, these are the 13 factors which are there. Out of that, they told the third one, thromboblastin, and the 13th one, that is your fibrin stabilizing factor. Both of this are actually formed by the platelets. The rest are all formed in the liver. Okay, now look here students, this is how a mesh formation happen. Look, don't you look, it looks like a web, no? It looks like a web, like a spider web. Now like this spider web, RBC will come and stop. RBC will come and stop. Clear? Okay, done. So this is your RBC. Okay, this is your mesh formation. This is the mesh formation. Okay, look here. Erythroblastosis fetalis. I don't know how many of you know this, students. Erythroblastosis fetalis is actually a condition. Now, condition in the sense, look here. So imagine father is there, mother is there. Father is there, mother is there. Mother. Now students, father is Rh positive. Father is Rh positive. Any blood group, he is positive. Mother is Rh negative. Rh negative means Rh is not there, so she is negative. She could be B negative, O negative, whatever negative she is. Okay, she could be any kind of, any blood group but negative. Now these two people got married. Shadi ho gaya. Okay, shadi ho gaya. They both got married. Now they are going to have a baby, right? Now that baby is Rh positive. So you'll be like, ma'am, why are you making it a big problem? So let's see, look here. If you can see here, you can see a woman with a fetus in the womb. Now, there is the baby who is Rh positive. And then there is the mother who is Rh negative. Now, what is going to happen? Normally, mixing up of blood will not happen. Mixing up of blood will normally not happen. Nutrients will be transported, everything will be transported, but mixing of blood will not happen. Then the question is, what is actually going to happen? Students, so mixing up of blood won't happen. But when the placenta ruptures, Okay, when the placenta ruptures, mixing up of blood will happen. Okay, mixing of blood will happen. Mixing of blood will happen. Now, when mixing of blood happens, what is going to happen? This mother's body does not know that it is my own baby's blood. The mother's body will see this Rh positive blood as a foreign particle. As a foreign particle. Yes or no? So the mother is Rh negative, baby is Rh positive. Imagine one blood got, like one negative positive got into the mother's body, or some positive Rh got into mother's body. Immediately the mother's body will recognize it as a foreign particle and start forming antibodies against it. Yes or no? The moment our body recognizes something as a foreign particle, it will start forming antibodies. Now this Rh positive becomes the foreign particle in the mother's body. What is the mother's body going to do? It is going to form antibodies against the own baby. Form antibodies for Rh negative. Sorry, Rh positive. Now, first baby, no problem will happen. Safely, the baby will be removed. The mixing or nothing will happen. Now, students, imagine they are planning to have a second baby. They are planning to have a second baby. Okay, they're planning to have a second baby. Second baby. Now, what happens, students? Imagine the second baby also is Rh positive. Second baby also is Rh positive. Now, what is going to happen? The body, the mother's body already has a memory of Rh positive. Yes or no? In the first instant, the mother's body had already formed antibodies if an Rh positive comes again. That is, our body memory will always be there. Once if a disease, a cold comes to us, second time if the same variant comes, our body will attack them. If a different variant comes, the body will not be able to recognize. Now again, okay, when the placenta ruptures, when the baby is inside the body, you know that antibodies get exchanged through the placenta. Correct. Now what is going to happen? The antibodies which is formed against the Rh positive will enter through the placenta inside the baby. Clear or not? Clear or not? I'll show you the image. Do not worry. Now, the Rh positive antibodies, right, will enter the second baby. Now, what is going to happen? What will happen? If soldiers enter a place with terrorists, what will happen? Murder will happen. Now, who is the soldier? Antibody is the soldier. Who is the terrorist? Rh positive is the terrorist for the mother's body. Now, the moment the soldiers enter the baby's body, it will start killing all the Rh positive. Now, because of this, this condition is called as Erythroblastosis fetalis. That means a condition where the second baby will be at risk. Okay, so this will lead to Erythroblastosis fetalis. Got it, all of you? Erythroblastosis fetalis. Why? Rupturing is happening of who? RBC. Correct. So here what is happening? The second baby will be at risk, and this is called as Erythroblastosis fetalis. Now you will be like, ma'am, how can I, check if my wife is like, if I want to marry someone, how can I check their blood positive? Like, are you Rh negative or Rh positive? We can't do that because there are a lot of people who have negative blood, a lot of people who have positive blood. One or the other day, there are chances that one of them get married, right? Now, can we keep taking care of this? No. So that's why we have a vaccine called as Rogam. We have a vaccine called as Rogam vaccine. What will Rogam vaccine do? It will actually go and attack the antibodies against Rh positive. Okay, it will go and attack the antibodies against Rh positive. So this way the second baby will not be in any harm. Now look here, all of you look at the image here. Okay, students, first condition. Okay, first condition in the first baby, this is from the first baby. From the first baby, some of the Rh positive entered the mother. Baby got delivered, nothing happened. Now, what happened? Against this Rh positive, antibodies have been formed in the mother's body. Right? Antibodies have been formed against Rh positive. Right? Rh positive. Now, look here, second baby happened. Okay, this is the second baby. Okay, second baby. Now what happened, students? I told you through the placenta, antibodies can enter inside. Can you see one antibody enter inside the babies? Inside the amniotic fluid. Can you see? Right? The antibody entered. Now what will it start doing? It will start killing the Rh positive. It will start killing the baby's blood. Right? Leading to erythroblastosis fetalis. Now to avoid this, we used Rogam vaccine. We used Rogam vaccine. Okay, now this Rogam vaccine will remove the antibodies against the Rh positive. Easy. Okay, Rogam vaccine will remove antibodies against Rh positive. This way, we can avoid erythroblastosis fetalis. Clear or not? We can avoid erythroblastosis fetalis. Easy? Yes? Okay, great. Okay, erythroblastosis fetalis. Okay. Then we have lymph. So before lymph, we'll take one small break. Okay, we'll take a very kuti break. Yes. Let's 123. Let's take a small break. 1:35 p.m. You can all be back. Okay. So students, are you all back? Let's see, let all of you go. Yes, students, I am back. Okay. Let's continue. Okay, next topic is lymph, right? Next topic is lymph. So students, before I read this paragraph, look here. This diagram shows it all. Now the blue color thing is water. Okay, this is dissolved substance and the purple one is WBCs. Now what is happening in the capillaries? From the capillaries, something is oozing out, right? Some fluids are oozing out. Now those fluids will ooze out, and that oozing out fluids are called interstitial fluids. Okay, interstitial fluids. Now this interstitial fluids will keep losing out. Now can the body afford to lose dissolved substance or water or WBC? Not possible. Why? Because everything is in correct number, everything is absorbed in correct quantity. When any of this increases, it becomes a disorder, right? Now what is happening? These things are oozing out. Now someone has to be there to protect all of this, no? That is by the lymph. So what is lymph going to do? Whatever interstitial fluids are coming out of the capillaries will be taken up by the lymph, and that is called as the lymph fluid. Okay, got it? Now with that understanding, let's try to read this. As the blood passes through the capillaries in the tissue, some water, very important, some water along with some soluble substances move out into the spaces between the cells. Okay, spaces between the cells, you can also call it interstitial spaces. Okay, spaces between the cells. Yes, spaces between the cells of tissues, leaving the larger protein and most of the formed elements in the blood vessels. So what is happening, students? Look at this image once again. All of you, capillaries are there. Okay, some things are oozing out. What and all are oozing out? Water is oozing out. Some formed elements are oozing out. With that, some WBC also is oozing out. Now they are oozing out from the spaces in between. Now body cannot afford to lose it. So body has made another system called as the lymphoid system, or the lymph, where it will take up everything. Whatever is coming, no, it will take, collect. Okay, so yes. Now understood that? Okay, into the blood vessel. This fluid released, important. This fluid released out is called interstitial fluid. That means the fluid which is coming out, squeezing out of the capillaries, okay, that is called as your interstitial fluid. Okay, now it has the same mineral distribution as that in the plasma. Who has the same constitution? Interstitial fluid has the same constitution as of in the plasma. So it is indirectly like we are losing the plasma. No? So exchange of nutrients, gases, etc. between the blood and the cells always occur through this fluid. Okay, so exchange of anything also happens because of this fluids. Okay, now an elaborate network, important students, an elaborate network of vessels called the lymphatic system. Okay, called the lymphatic system collects this fluid, okay, and drains it back. Okay, they first collect it. Think of this like a filter. First collecting, then draining back. Okay, collects, drains it back into the major veins. So this lymph is just not collecting and just sitting and be like, oh, I have collected, my job is over. No, they're actually collecting and they're giving back to the major veins also. Okay, whichever is needed, whoever is needing it, they're giving back also, which is a good thing, right? Body needs it. Okay, now the fluid present in the lymphatic system is called the lymph. Okay, this is what I told you. The fluid which is present in the lymphatic vessel is called the lymph. Lymph is a colorless fluid, contains specialized lymphocytes. Okay, what is the cells they have? Specialized lymphocytes. Okay, yes, which are responsible for immune response. Now, whom are they talking about? They're talking about your B cells, B lymphocytes and T lymphocytes. These two people are helping in what? Cell-mediated immunity as well as for memory cells and plasma cells. B cells have both plasma cells and memory cells. T cells are helping in cell-mediated immune response. So this lymph has lymphocytes which are actually helping in the immune of our body. They actually keep the memory that, oh, this virus had come once, no? Now I need to protect. So starting, if they're making 10,000, second time they'll make 30 lakhs or 10 lakhs against them. That's like, you know, when sometime like imagine a guest came home. First they did not invite, or first they did not inform you. So you will have normally water will be there, some namkeens will be there, some small snacks will be there. Second time they're informing and coming. If that person matters to you a lot, second time you will make as many dishes as possible, right? Same way. First time something comes, body will not be that prepared. Second time they come, body will be triple prepared. Okay, that is what they're talking about here. Lymph is also an important carrier for nutrients, hormones, etc. Fats are absorbed through lymph in the lacteals present in the interstitial villi. All of you know about villi, right? All of you know about villi, like this finger-like projections. What do? They increase the surface area in the intestine. Okay, that's all about lymph, students. That's all. NCERT, only that's all it's saying. Okay. Now, yes, this is clear. Now, students, very, very important topic, heart. Are you all ready to learn heart? Yes or no? Let me know. Are you all ready to learn about heart? Okay, let me see the chats. 1 second. Yes, are you all ready to learn about heart, students? Heart is very, very important. Yes or no? Right. So, first thing about heart that you need to know, it is located in the mediastinum. Where is it? Between the lungs. Okay, between the lungs, there's a portion called as the mediastinum. You'll study this in locomotion. Proper locations you will study. So, it is present in the mediastinum. Okay, yes. Where does it actually fit? It fits into a cardiac notch. Okay, it fits into the cardiac notch. Okay, that's why, have you seen? Heart is a little towards the left. See, look, did I put the heart straight? No, it's a little towards the left, and it is a slightly triangular in shape. Slightly triangular in shape, and it is slightly tilted. Tilted to the left. That is because this is actually present on the cardiac notch of the left lung. So it is pushed a little to the left. Clear or not? Okay, what is the size of your heart? Size of your heart. Student, size of your heart is how much your fist is there. This is the size. Fist. Your fist size is your heart size. Okay. So it is the size of your fist. Got it, all of you? All of you have heard this, I think, when you were smaller classes also, your ma'am would have told, students, do you want to know what is the size of your heart? Fold your fist. Right? They should tell like this. Fold your fist. So, fist size. Okay. Now, students, understand, in male and in female, heart size grams vary, weight varies. How much it varies? Okay. So, men have a little more bigger heart. They have more space, okay, for more people to be inside. So, 340 grams. Okay. 280 to 340 in grams. Okay. And for females, it is 230 to 280. Okay, 230 to 280 grams. So, females have smaller, the weight is lesser, but males have more. Clear? Clear? Okay, students. Now we have to understand. 1 second, let me see if I have left space for. Yes, okay, that I will discuss with you. Students, two types of circulatory system is there. You know, when we talk about heart itself, you know that we learn about heart in our circulatory system, right? So here also two types of circulatory system are there. Open and closed circulatory system. Okay. open and closed circulatory system. Now what you're seeing here is an open type of circulatory system. Okay, it is an open circulatory system. Yes, open circulatory system. Now why am I telling it's an open circulatory system? Students, look here. This is the heart. Okay, these are your blood vessels. Here, can you see space is there? Space is there between them. So this open spaces are called as sinuses. What are they called? Sinuses. That means blood is flowing, but they do not have capillaries. So it is an open type of circulatory system. That means blood is not going through a proper network. Right now you're pumping water from the motor to the tank. Proper pipe system is there. Proper tube system is there. Same way, imagine somewhere it broke. Somewhere it opened. Right? Some connection between two pipes opened. All the water will go out. Right? Here also there's a small opening called as, that open spaces are called as sinus. That means they do not have capillaries like in the closed circulatory system. Clear or not? Easy? Yes? Easy to understand? Easy, no? Yes, okay, fine. Okay, so students, open spaces, that means sinuses. Okay, sinuses, they are the spaces because of which this is called as an open circulatory system. Open circulatory system. Okay. Yes, fine. Done. Yes. Now, don't we have to know the examples? Yes, we have to know the examples. Students, examples of your open circulatory system is arthropoda. If you have all learned cockroach by now, because it is there in your NEET portion, you would have learned about cockroach. You would have learned that it is a open circulatory system. Okay. Then there are exceptions. Exceptions, that is your cephalopod mollusk has open circulatory system. Okay, usually cephalopods entire, that is the mollusca, the entire mollusca has closed circulatory system except the cephalopod mollusk. Okay, except the cephalopod mollusk. Even leeches are an exceptions from annelida. Okay, annelida. Leeches also are an exceptions. Okay, this much clear. That thing, students, only sinuses you have to know. That means open spaces through which the blood will just pass. Okay, they do not have any restriction. They can just see. Imagine your gate are always open in your hostel. That means what? You will always go out. No, you will always have a tendency to go out. You'll be like, oh, gate is open, no restriction. Why will I stay inside? I will go out. But imagine gates are closed. You need permission. Then you'll be like, oh, I have to fight with that security guard. I have to ask my mom. I have to ask my dad. Why will I do so much of it? I will just stay home, right? I will just stay in hostel or I will just stay in home. So that is the thing. Okay. Yes. Now let's see closed circulatory system. So in first difference itself, you know, no? Closed circulatory system. Here you see no sinuses. Instead of sinuses, what do they have? They have capillaries. Okay, they have capillaries. That means what? That gate, that proper network is there. Okay, proper network is there. Okay, and can anyone tell me which was the first phylum to have your closed circulatory system? Annelids. Okay, Annelida was the one which was the first phylum to have, okay, first phylum to have closed circulatory system. Okay, then I told you mollusk, right? Mollusk, again exception is there. Even in annelids, leeches are exception. The leeches are exception. Clear? Mollusk also, cephalopod mollusk are exceptions. Clear? These are the exceptions. Then we students, vertebrates, that means your mammals, all of that, right? All the vertebratas will have closed circulatory system. right? Vertebrae. Clear? Easy? These are basics, okay? These are basics. Now students, very, very important topic is your heart of fish and amphibian, okay? So in animal kingdom, you will learn this in detail, but here I'll just tell you what are the types. So students, look here. Fish or your pyqs. Okay, let's write it fish only. Fish is there. Amphibian is there. Reptiles. Okay, reptiles are there. Then we have mammals. Now students, understand fish. Okay, fish has two-chambered heart. Fish has two-chambered heart. This is heart, okay? We are drawing box heart. Amphibians have three-chambered hearts. Yes. Oh. Yes. Three-chambered heart. Both amphibians and reptiles have three-chambered hearts. Correct? Agreed, all of you? So let's draw it off in the middle only, no? Two-chambered. This both have. Okay. So let's write also. What are they? So this is my left hand. So it becomes my right side. Right, left. Okay. Right atrium, left atrium, and ventricle. Both of these people have. Out of this reptile's crocodile has four-chambered heart. Okay, four-chambered heart. Who has? Crocodile has four-chambered heart. Mammals, we also have four-chambered heart. Right? We also have four-chambered heart. Right atrium, right ventricle, left atrium, left ventricle. Simple? Yes, simple. Okay. Now students, understand. Heart of fish. Heart of fish we have to learn. Okay. So, let's draw like this. Okay, four chamber like 1, 2, 3, 4. Okay. It might look like a worm, but it is not a worm. Okay, it's not a worm. I'll tell you why. Yes. Okay. So look here. This is heart of a fish. Okay. Here also we will draw two valves. Yes, two valves. Okay. Now what is happening, students? It's coming. Okay. Now blood is entering. Right? Blood is going to enter. Okay. So now you see four chambers. In that the first one is your sinus venosus. Sinus venosus. Here you have your atrium. Here you have your ventricle. This is okay. So students, these are additional chambers. What are they? Okay, additional chambers. Okay, coronus arterios. Coronus arterios. So these are additional chambers. We have sinus venosus, coronus arterios. Now imagine blood is entering. Who's entering? Blood is entering. Okay. Yes. So students, look here. Imagine from the body deoxygenated blood is collected. So from the body parts, the blood is going to enter. So let's write here body parts. Okay, body parts. Now students, blood is entering. All of you agree? From a body, all the dirty materials, all the carbon dioxide, everything is taken and the blood is moving inside. Oh, 1 second. Yes. Blood is moving. It is entering. Sinus venosus. From sinus venosus, it will go to atrium. Atrium to ventricle. Ventricle to coronus arterioles. And then it will come back. Where will it come back? Where will it come back? It will come back to the gills. Okay. So it will come back to the gills, which will purify the blood. Like how we have heart. These people have gills, which will purify the blood. And now what is going to happen? That blood will be transported to the different body parts. Clear or not? So purification is going to happen where? In the gills. So students, do you notice here what is happening? Blood is entering from all the body parts. It's going through all the four chambers, right? Four chambers, in that two are additional, accessory. Okay. And it goes to the gills. Gills will purify. That will go to the body part. That means blood is going only one round inside the fish body. Okay. It is going only one round. So it is a circulation. It is a single circulation. That means the blood is going only one round inside the fish body. Yes, one time inside the fish body. Okay, simple. Okay, that's because the blood is going one time. Now, students, amphibians. Okay, let's erase mammals because we will do mammals in depth. Okay, mammals. Students, here, amphibians and reptiles know what is happening. This thing is happening, right? Two chambers are there, right? This is what is there. Now look here, all of you. Right atrium, right ventricle. No, right, sorry. Left atrium, ventricles. Ventricles are together. So here also, students, what is going to happen? Let's draw the same color. One deoxygenated is coming, one oxygenated is coming. Okay, say deoxygenated is coming. Okay, oxygenated is coming. Now both of them will mix up in the ventricle. Oxygenated, deoxygenated. Both are going to mix in the ventricles, because of which they are able to regulate their body temperature, right? Mixing up of blood happens. Mixing up of blood happens. Yes or no? Mixing up of blood is happening in the ventricles in the case of who? Amphibians. This is amphibians. Okay, yes, this is in the case of pyqs. Okay, so here mixing up of blood is happening. Because of this mixing up only, they are able to regulate their body temperature. Done, dusted? Done, dusted? Yes? Great. Okay, students, coming 1 minute. Sorry, students. Okay. So, students, is this clear? Okay. There was a small glitch, so I went to fix that. Yes, so this is clear. We did heart of fish and we did heart of amphibian. So heart of fish here, it does single circulation. Here what is happening? Deoxygenator also is coming, oxygenator also is coming, it's mixing. So mixing of blood is happening. Okay. Now we will start with our human heart. Okay, now we will start with our human heart. But before that, we need to understand few things. Okay. Yes, ready? Ready? So students, we are going to understand human heart. Okay, very easy topic. Do not get tensed. Ma'am, I can't understand. Do not be panic. See, first we'll understand wall of heart. Wall of heart. Students, heart is a very precious thing. Yes or no? Very, very precious thing. So you need to have that kind of a protection. Like how our brain is protected. If all of you know, we have dura matter, arachnoid, pi matter, all this to protect our brain. Yes or no? We have a transparent layer, we have a very hard brain box, cranium, all this to protect our brain. Same way we have to protect our heart also. So students, to protect our heart, there is 3 walls actually. Okay, 3 walls. First one is your outer wall. Okay. Then you have your middle. Then your inner. Right? These 3. Every time there's outer, middle and inner. Okay. Outer is called as epicardium. What is it called? Epicardium. Middle will be what, students? Easy to get. Middle will be what? Myocardium. Myocardium. Then what will be the inner wall called as? What will be the inner wall called as? Endocardium. Okay, so 3 walls are there: epi, myo and endocardium. Okay, now let's try to understand what are these people made up of. Okay, what are these people made up of? Right? Ready? Okay. So students, this epicardium is again divided into serous pericardium. Okay. And it is also divided into fibrous pericardium. Okay, 2 parts. I'll draw and show you fibrous pericardium. Clear? Okay. Myocardium. The word myo means what? Cardiac muscles. It is made up of cardiac muscles. Okay. Yes. So let's do one thing. Let's write pericardium with the pericardiums down. So we will be having space to draw. Yes. Serous pericardium and we have fibrous pericardium. Okay, done. Now, inner, that is your endocardium, has a simple squamous epithelium. What does it have here? So here I told cardiac muscle. Here we have simple squamous epithelium. Okay. Yes or no? Simple squamous epithelium. Okay. Now let's start drawing it. Let's use the same colors, but I haven't used any same colors. Okay. But it's okay. Let's just start drawing a sketch of it. Yes. Okay. Students, okay, let's start drawing. Then I'll tell you. So, okay. Okay. Look here, students. Okay, let's try to understand what are these layers. Okay. So between this portion which you're seeing here, okay, this is your visceral pericardium. You'll be like, ma'am, you didn't even tell about visceral pericardium. Okay, and between this pericardium, there is a fluid called pericardial fluid. What is it called? Pericardial fluid. This is called as fibrous pericardium. Correct? Fibrous pericardium. Okay. Now, students, this is visceral pericardium. Like that, we have one more layer which is called the parietal pericardium. Okay, I'll tell you where this is coming. Okay, parietal pericardium. Now, understand this visceral and parietal pericardium together belongs to this person. Who is that? Serous pericardium. Okay, serous pericardium. Who are all? Visceral and parietal together will come under serous pericardium. Between the visceral and the parietal, there is a space which is filled with your pericardial fluid. Okay. Now, the green color which I have drawn here is your endocardium. This last layer. Okay. Then in between, we have myocardium. We have myocardium. Let's see if we did all the layers. Serous pericardium, we have visceral, this one and this one, right? Visceral and parietal. Fibrous pericardium, yes, we did fibrous pericardium. Then myocardium, yes, we did myocardium. Then we did endocardium. Okay, students, actually this layer will be attached to this only. There won't be the space. Okay, there won't be the space. So we will also attach and draw. I don't want any confusion. Okay, students, like this. Right, okay. These are the wall of the heart. Now, this many walls are there to protect our heart so that no injuries happen. Now, one of the reasons why we have pericardial fluid is because it acts like a lubricant. It acts as a lubricant. It also acts like a shock absorber. Shock absorber. That is the reason when suddenly a jerk happens, like you're driving, suddenly a dog is crossing or something happened and you jerk. Your heart, nothing is going to happen, right? That tension will be there, but the jerk will be protected by your pericardial fluids. Clear or not? Easy? Okay? Yes. Fine. Now let's draw the heart. My God. Let's draw the heart. Are you all ready to draw the heart? Yes or no? What is happening? Phone is giving. Yes, ready to draw the heart? Okay. Students, so does it look like a heart? Yes, it looks like a heart. Yes or no? It looks like a heart? Fine. Now, let's draw it with... Okay. Now, let's draw our outer layer. So, though that muscles are not very, like, proper, like straight line types. They are a little wavy. So, you can also draw it that way. Yes. Okay. Yes, done. Beautiful heart, isn't it? Yes or no? Like the heart? Yes, okay, done. Now, we have some main portions to draw. Okay, here we have a small circular structure. Okay, then let's draw that much. Then we will slowly start labeling income. So students, this is my left side, this is my right side. So this becomes the right atrium, right? I'll write it very small. Okay, this will become my right atrium, right ventricle, left atrium, left ventricle. Yes or no? Correct? Okay. Now, simple things. Starting, we'll do just simple things. Now, blood has to be brought to the heart, to the right atrium with the help of two vena cavas, right? Two vena cavas are going to bring the blood. Who are those people? Superior vena cava and inferior vena cava. So, shall we draw that? So, we have superior vena cava, which is bringing blood to the right, okay, right atrium. Then we have inferior vena cava. Okay, yes or no? Two vena cavas, superior and inferior. Let's label also. Okay, this becomes superior vena cava or the precaval, and this becomes the inferior vena cava or the postcaval. Yes, postcaval. Okay, this is simple. Superior vena cava, inferior vena cava, both are bringing deoxygenated blood, and it is dumping where? It is dumping into the right atrium. From where are they bringing the blood? They are bringing the blood from the upper and the lower part of the body. Okay, this much clear. Now students, I have drawn one circle. Okay, all of you notice I have drawn one circle in the between, right? What is that called? What is that called? This is called as coronary sinus. What is it called as? Coronary sinus. Yes? Done. Coronary sinus. Okay? Now, this coronary sinus, I'll tell you more about it. But before that, you have to erase one kutti line. Okay? Right, let's... Okay, 1 second, students. Are you able to draw with me, all of you? Easy, I'm drawing simple. I'm not complicating the diagram. I just want you to understand the internal structure. Rest you will study in your MBBS. Full in depth you will study. Okay, now try to understand. Since here, there is one, like this one ridge inside. Okay, like this down. A ridge is there. I don't know if you'll be able to see the ridge properly. Yes. So students, understand. Superior vena cava is placed in an angle. So the chances of blood backflowing is very less. But inferior vena cava is downwards. That means deoxygenated blood can go back, right? Backflow can happen. Same way this coronary sinus also. Coronary sinus actually provides blood to the heart. Also is an organ. Heart also needs the blood, right? So you remember you had coronary artery, you have muscles, right? All these people, blood will be given, and that blood will be like the deoxygenated blood from the heart will be given out by the coronary sinus to the right atrium. Now both of this, coronary sinus and the inferior vena cava, can have backflow of deoxygenated blood. So to avoid that, we are going to keep valves for them. What are we going to keep? Valves for them. See here I am keeping a valve for the inferior vena cava, and for coronary sinus also I am keeping a valve. Yes, both the valves names are different. It is not the same. Both the valves names are different. So students, the valves present on the... Oh, 1 second. Yes. The valves present on the inferior vena cava. Can anyone tell me the name of the valve? Yes, easy it is. Valve of Eustachian. Have you ever heard that? Valve of Eustachian. Now, coronary sinus also has valves, right? That is called valves Thespacious. Okay, Thespacious. So valves of Thespacious. That means valves on the coronary sinus. Why? To avoid the backflow of blood. Okay, to avoid the backflow of blood. Okay. Now we did all the normal things. Now we have more work, right? We have more work. Now students, there should be valves, no, on between to separate the right atrium and the right ventricle. So before that, students, do you see this thick layer? Do you see this thick layer? They are all called as septum. That means to do the separation, to make us understand the separation. Yes or no? Clear, all of you? I'm moving to one side so all of you can copy it down. So students, I told you there is a ridge here. Okay? If you, I don't know how many of you can see, there is a ridge here actually. Okay, I'm highlighting it with another color. Students, this ridge is actually fossa. Okay, it is called as fossa ovalis. This is actually an scar that is present from the that is your foramen ovale. Now, what is all these terms, ma'am? What are you telling? Students, have you ever heard people telling this child died because of the hole in the heart? Actually, when you're in the embryo stage, mixing up of blood happens. It does not cause you any damage. So, that mixing up is happening because of foramen ovale. Okay, foramen ovale is the initial. When in the embryo stage, there will be an opening here. Now, as you grow up, that will get closed. That forms fossa ovalis. Now, in case fossa ovalis is not closed, that means foramen ovalis does not close and it does not form fossa ovalis, then we say hole in the heart. So, what is going to happen? Deoxygenated blood and oxygenated blood will mix and that baby will end up, okay, which is a scar of the foramen ovalis, which leads to the term called as hole in the heart. It is not the literal term like hole in the heart. This is actually because closing is not happening, right? Closing is not happening. So what will happen? Mixing up of blood will happen. Clear? Yes. Now students, we have to label some septums, right? So here, this septum which you see, they are the septums between two auricles. So can I call it intra-auricular septum? Yes. Can I call it intra-auricular septum? Easy. Now, the septum between both the auricles, intra-auricular septum. If you label with me, it will be easy. Otherwise, it will be like, oh my god, ma'am labeled so much. Inter-auricular septum. The septum between ventricles will be interventricular septum. Okay. Now, students, do you see there are some ups and downs like our life? No, there is some ups and downs, right? Now, students, those ups and downs are actually not just being there to beautify the heart. Okay, they are not there to beautify the heart. They are actually your papillary muscles. What are they? Papillary muscles. So, the smaller one, like which one is going down, no? The smaller ridge is called as the they are the papillary muscles. Okay, they are the papillary muscles. I hope all of you are able to see. I'll move all the time. Now, students, smaller ridge and upper ridge is there. I'll tell you about it. Okay. So, this upper ridge is called as papillary muscles. Can you see here? I have labeled the upper ridge. That means, students, in a wave, this is the upper portion, this is the lower portion, right? So, in physics, you would have studied, no? Compression, rarefaction, right? All this you would have studied in physics, wave chapter. So, same way, this upper region is called the papillary muscle. So, there is a smaller ridge. Can you see here? There's a smaller ridge. Let me do this part. Smaller ridge. Okay. That smaller ridge is called as columnar. Okay, this word is tongue twisting me. Okay, smaller ridge. Channel. Okay, Columnar shanning. Okay, it's like a very fancy word. That's why tongue is twisting. Okay, smaller ridge done, higher ridge done. Okay, now let's learn the valves. Let's learn the valves. So you see, one valve is here. Okay, one valve is here. This is actually your tricuspid valve. Between the right atrium and the right ventricle, what you are seeing is your tricuspid valve. Okay, I'm labeling it. What is it? Tricuspid valve. Why is it called tricuspid valve? Because this valve will have 3 openings, right? Right, 3 openings like this. It will have 3 openings like this. That is why it is called as tricuspid valve. Okay, clear? Now, same way we have bicuspid valve, right? We have bicuspid valve or the left auricular valve. So, where does that be present? Here. Okay, here. Okay, here. You see? Okay, lines are going all the place. No, wait. Yes. Wait to right, wait to right. Yes. So this is called as bicuspid valve or mitral valve. Mitral valve. Yes, mitral valve. Clear or not? Heart diagram is clear? Okay. Now, we have pulmonary vein, right? We have pulmonary vein which is opening to the left ventricle. Left auricle. Right? We have 2, actually 4. Since we have 4, actually here also 2 openings will be there, which you cannot see because it's coming from the back side, right? It's coming 3D, I cannot draw. So it is coming from the other side. So here 2 openings, here 2 openings. So what are they? Pulmonary vein. Right? Pulmonary vein. Clear or not? Pulmonary vein. Now what is happening, students? Deoxygenated blood and oxygenated blood. So deoxygenated blood came, it will pass all the way from the right atrium to the right ventricle, right? From there, it has to go where? It has to go to the heart for oxygenation. Then, after oxygenation, it will come to the left auricle. From left auricle, it will go to the left ventricle. From left ventricle, it will be taken by to the all the body parts. Yes or no? Simple, easy, easy. Let's see if we missed something. Did we miss something? No, we did not. Okay. Are we clear on this? Can you all tell me in the chat box? Are we clear on this? Yes. Students, there are coordinate tendines. Okay, coordinate tendines which are connected from this papillary muscles to this. Okay, to this portions. But I'm not writing it because it becomes too complicated. You will not be able to understand the diagram. That's why I am avoiding that. Okay, I'm not writing that. But just understand. Just understand from this. See, from the papillary muscles. See, I will just draw just for your understanding. So from the papillary muscles, like this, they will be connected. Will be connected like this just to prevent the backflow of blood. Okay, not only here, here also will be present like this. Okay, will be present like this just to prevent. They are called as coordinate tendinae. Coordinate tendinae. Okay, can you see that? Coordinate tendinae. They will just prevent the backflow of blood. Okay, I'm not drawing it. I think I'll draw it on one side. Maybe I'll erase this and draw it here. Right, just to make you understand. Okay, so here we have, second. Yes. So what do we have? This coordinate tendinae. Okay, cornea tendineae. Okay, students, now this heart, from here, understand, from the left ventricle, aorta will come out. Right, aorta will come out. If you draw aorta, yes, I'm taking my time and teaching you, otherwise it will become confusing. Okay, it will become confusing. Students, same way from the RV, that is your right ventricle, valves will take it to the heart, right? Valves will take it to the heart. Not valves, blood vessels will take it to the heart, right? Same way, aorta also will take oxygenated blood and give it to all the body parts. Any doubt on this? Okay, we have pulmonary artery to take the blood from here. Okay, so we will just draw that. We will see how much we can fit in. It might look very clumsy. Let's say I am... Okay, let's try, students. So students, from here, there's one person who is going to come and take it to the heart. Okay. Who is that person? Pulmonary artery. Yes, pulmonary artery. PA, I'm writing pulmonary artery. Same way, oxygenated blood will go, that is, oxygenated blood will be taken by the aorta, right? By the aorta, and it will split into 3 parts. Okay, it will go all the way, right? It's a little messy. That's why we will just write it. Okay, we will write it because too messed up, right? We cannot understand the heart diagram. So I'll write that separately for you people, but just understand. Okay, 2 people are coming. One person will take the deoxygenated blood and go to the heart. Another person will take the oxygenated blood and go to the heart, right? That much you please understand. Yes, fine. Let's go to the next one. So students, here I've just put a diagram. This is, please understand. See, can you see? The pulmonary artery takes the deoxygenated blood to the heart. Aorta takes it to the other body parts. Okay, shall we write it? Okay, yes, great. Okay, let's write it. Okay, students, we will write it in the form of box. Okay, box is the easiest way to understand the heart. This is the heart. This is your heart. Okay, right auricle, right ventricle, left auricle, left ventricle. Yes. Okay. Now, what is happening? Down we have body, right? Tissue. Let's draw tissues. Then who is going? Oxygenation. Okay, it will, students, sorry, pulmonary artery, from the heart, it will go to the lungs, okay, for deoxygenation. I think I kept telling heart instead of lungs. Okay, lungs for oxygenation. Okay. Lungs for oxygenation. Who is taking? Pulmonary artery and aorta. Aorta will take oxygenated blood to different body parts. Pulmonary artery will take blood from the heart and go to the lungs for oxygenation. Now, with whatever understanding we have, let's try to draw this. Okay, let's try to draw this. Okay, yes, ready? Okay, students, what is happening? From tissues, we are taking deoxygenated blood. For all deoxygenated, I'll be drawing blue color. Okay, all blue color I'll be drawing. So, students, from the tissues, deoxygenated blood is going to come to the right atrium with the help of vena cavas. Right? I'm going to write here vena cavas. This is the best way to study this. Okay, vena cavas. So, from the body, deoxygenated blood is coming to the right atrium. From right atrium, it's going to go to the right ventricle. In between this, right? In between this, we have a valve. This valve is called the tricuspid valve, right? Between this, we have a tricuspid valve. So, the pink line I have drawn here is your tricuspid valve. Yes, fine. That is clear. Okay, blood is moving to the right ventricle. From the right ventricle, who is going to take the blood? Come on, tell me. From the right ventricle, who is going to take the blood? One person has to take the blood. Yes, that person will be none other than your pulmonary artery. Who is going to take the blood? Pulmonary artery. Pulmonary artery will take the blood to the lungs. Yes or no? Okay. Oxygenated and deoxygenated. Any doubt? Yes. Now pulmonary artery took it to the lungs. Lungs will oxygenate it. Right? Lungs will oxygenate it, purify it, and give it to whom? Give it to whom? To the left atrium. Right? To the left atrium, who is bringing? Who is bringing the blood? Can anyone tell me? Pulmonary vein. Okay? Pulmonary vein will bring the blood to the left atrium. Okay? Pulmonary vein will bring the blood to the left atrium. From the left atrium, it is going to the left ventricle. No doubt in this. Here we have a valve. Who can tell me the valve here? Let's draw it with orange color. Here we have a valve. What is that valve called? Bicuspid valve. Bicuspid valve. Students, now this much is clear. Now from the left ventricle, who is going to take the blood? From the left ventricle, who is going to take the blood and give it to the tissues? Aorta? Yes, aorta is going to take the blood from the left ventricle and give it to all the body parts. Okay, that's all. That's all is your heart. Simple. Simple. Okay, you do not even have to worry. Yes. So students, from this vena cava blood is coming. Other than that, we have additionally one more person. Your coronary sinus. Don't forget that person. Coronary sinus. That person also is giving deoxygenated blood to the right atrium. Then the right atrium is purifying. Okay? Done, done. Yes, done. Okay, fine. Okay, blood circulation. Now I taught you the circulation. Now let's see. This one is called, with the help of pulmonary artery, pulmonary vein, that is called as your pulmonary circulation. Systemic circulation is the down part. That means tissue to the vena cavas, to the right atrium, to aorta, to the ventricles. All this portion is called as your systemic circulation. Clear or not? Pulmonary circulation, systemic circulation. Yes, done. So students, how is it happening? See, lungs to the heart, heart to the tissues. Yes, lungs to the heart, heart to the lungs. Okay, I'll write it here. Okay, look here. Lungs to the heart, heart to the lungs. Okay. Now lungs to the heart, what is going to come? Lungs to the heart, what is going to come? Oxygenated blood is going to come, right? Oxygenated blood is going to come. Oh. Oxygenated blood is going to come from the lungs to the heart. Okay. Now who is going to bring oxygenated blood? Pulmonary vein. Any doubts in this? I'll write that also. Pulmonary vein. Now heart to the lungs, deoxygenated blood. Pulmonary artery. And this is called as pulmonary circulation. Clear or not? This is called as pulmonary circulation. Okay. Students, there's no way that you did not understand this chapter if you're in this class, because I have broken down it as easy as possible, as simple as possible. So if you have listened to the class, you are definitely going to get 16 marks from this chapter. Otherwise, I'm sorry to say, you will lose all your marks. Okay, done. Now students, tissue. Tissue to heart. Heart to where it will go? Where it will go? To lungs? Yes? Heart to tissue. We should have class. Okay. So students, what's happening? Tissue to heart, heart to tissue. Yes. Now let's see what is going. Okay. I have to keep adding colors. Okay, 1 second. So students, tissue to heart, deoxy. Deoxy is going. Who is taking? Vena cavas are taking. Vena cavas are taking. Yes or no? Now, heart to tissue, oxygenated blood. So easy, see? So easy. If you had attended Gopika ma'am's class, you would have answered all of this. Okay? Oxygenated blood is going. Who is going to take the oxygenated blood? Aorta. Right. Okay. So this is your which type of circulation? This is your systemic circulation. Systemic circulation. Done. Yes. Okay. Fine. Okay. Better than this diagram. We have understood it. Right. Now students, cardiac cycle. Cardiac cycle means what? Our body, our heart goes through a cardiac cycle. That means around one cardiac cycle is around, okay, one cardiac cycle is around 0.8 seconds. 0.8 seconds. Okay. That means 60 seconds, 72 times our heart is beating. Right? So 1 second, how many times? So one beat. One beat, one cardiac cycle. Okay. So one beat is called one cardiac cycle. Okay. One beat is called one cardiac cycle. One cardiac cycle takes around 0.8 seconds. Okay, students, same way you should know diastole and systole. Okay, diastole and systole. Students, diastole and systole, contraction happens. Heart contracts, right? That time it is called as systole. Okay, you can remember it as Christ School. CS. Okay, Christ School. Now, when contraction happened, relaxation has to happen. Diastole. Okay, RD. Okay, diastole. So, contraction, systole, relaxation, diastole. Contraction, systole, relaxation, diastole. Clear? Okay, keep all these terms in mind. Very, very important. Okay, students, now we'll understand. We're almost coming to the end of the chapter. So, let's finish it. Right? Yes, okay. Students, now we are going to understand about your cardiac cycles. 3 types. That means 3 events happen in the cardiac cycle. What happens? 3 events. 3 events happen. Now, these 3 events, 1 minute. Let me do one job here. Yes, okay, fine. Now, students, cardiac cycle happens in 3 events. Okay, those are the events that we are going to see here. Fine, let's split this cycle first. Got it. Okay, now from here, yes. Okay, so first event that happens in your cardiac cycle is your arterial systole. What happens? AS, arterial systole. Then what will happen, students? If arterial systole is happening, definitely ventricular systole will happen. Systole means what? Relaxation or contraction? Contraction. Okay. CS, Christ. Then students, joint diastole will happen. What will happen? Joint diastole will happen. Okay. So arterial systole is the shortest. Arterial systole is the shortest. It will happen only for 0.1 second. VS, that is your ventricular systole, will happen almost for 0.3 seconds. Okay. 0.3 3 seconds. Then your JD, 3 plus 1, 4 is over. Out of 8, we have 4 more. Yes. So 0.4 seconds will happen in the JD. Okay, JD is your joint diastole. This much clear? Now, AS, okay, AS, what are the events that happen? Students, arterial systole means what? Both the arteries are contracting. Simple. Both atriums are contracting. Okay, that's the first thing you need to know. Then what do you know? AV valve will open. Now, who is the AV valve? That is your tricuspid valve, right? Between both the auricles, between auricle and ventricle, there should be a valve, right? AV valve. All of you remember AV valve? Wait, let me see if I labeled it for you people. Tricuspid, bicuspid, yes, I labeled. Did I not label that valve for you people? Okay, students, between the same thing. Tricuspid valve is also called as Arterioventricular valve, AV valve. Okay, so here what is going to happen? AV valve will open. Okay, students, when the valve close, sound will come. When the valve open, no sound will come. Right? Got it? Fine. This much understood. Now, students, understand. Now the valve has planned to close. Okay, valve will plan to close. So here, when the valve closes, who closes? AV valve closes when it's going to the ventricular systole. Right? In auricular systole, what happened? Both the atria closed. AV valve opened. Okay, and it allowed the great veins to come. Okay, yeah. So the route of great veins were closed. Now, what is great veins? Your vena cava, pulmonary vein, all of this. Okay. Now, students, the AV valve has planned to close. So I told you, when closing happens, one sound comes. What did I tell? When closing happens, one sound comes, and that is none other than your lub sound. Lub. Dub, lub, dub, lub. That's how your heart makes sound, no? First, lub sound will happen, okay? When the AV valve closes. Then, look here. Second, your ventricular systole. Now, you know auricular systole, what happened? Both the auricles, okay, contracted here. What is going to happen? Both the ventricles contract. Both the ventricles contract. Yes, clear? Now here also some valve opening or if no valves opening, we have to see. So students, here semilunar valves are opening. Semilunar valves are opening. Okay, semilunar valves are opening. Yes or no? Clear? Okay, that much we did. Semilunar valves are opening. Students, I will just write here. Students, semilunar valves are present on the pulmonary artery. Okay, it is present because we did not label it there. I'm writing it here. It is present. Oh, it is present on the pulmonary artery. Okay, that is what is semilunar valve. So, semilunar valves are open. Okay, they have opened. That much clear? Now, what is going to happen? It is going to the next phase. That means semilunar valves will plan to close. Right? Semilunar valves have planned to close after 0.3 seconds. Here, dup sound will come. Dup. Okay? Dup sound will come. Yes? Easy? Okay? Then, students, your last one, that is your JD. That is the joint diastole. That means he's telling all of you relax. Why are you doing so much of work? Just relax for some time. Right? Relaxation is going to happen. And here, closure of semilunar valves. Okay? That is the event that has happened. Yes, that's when sound came. Okay? Then what has happened, student? Ventricular filling will happen, where 70% is filled by JD. Rest, your 30% will be filled by AS. Okay? What is going to happen? Ventricular filling is going to happen, out of which 70% will be filled in the joint diastole, 30% will be filled in the AS, that is your arterial systole. What is ventricular filling? The ventricles got completely full. Okay. So 70% full happens when there is a joint diastole. 30% is going to get full when it is in the AS, that is your arterial systole. Easy? Easy? Yes or no? Okay? Fine. Yes. Okay. Students, questions can come. The gap between your dup and lub and dup, all that. Okay, so you have to think. It will not go reverse. So if they ask from dup to lub, it has to go this way. Okay, that means 0.4 plus 1, 0.1 second. So the gap between your dup to lub, okay, you cannot do like this. You have to always go in a circle, right? That will be how much? 0.5 seconds. Clear? 0.5 seconds. Okay. Yes. So students, do you know who is the longer duration one? Your lub is a longer duration one. Okay. This is a shorter duration one. Dup is a shorter duration. Lub is a longer duration. And who is lower pitch? Lub is lower. L stands for lower. Think like this. Lower, longer. Okay. Dup is shorter. Shorter duration, high pitch. L for longer, low pitch. D for nothing is there. So you'll just remember the opposite of lub. Clear or not? Fine. Let's go. Longer duration, low pitch. Yes, these two things I told you. Okay, closure of which valve? Closure of tricuspid valve. Or in other words, AV valve. Okay, this fellow, who is this fellow? Your dup. Lub. Okay. Since your dup, what is happening? It is, here it is longer. So here it is shorter. I'm sorry. Okay. Students, shorter duration. Here it is high pitch. Closure of what? Semilunar valves. Agreed, all of you? Closure of semilunar valves. Easy, easy peasy. Right? Yes. Yes. Semilunar valves. Okay? Done or not? Yes. Okay. Shall we do blood vessels? Yes. Students, look here. This is your blood vessels. Your first layer in the blood vessels is tunica externa. Second layer is called tunica media. Third layer is called tunica intima, or you can say tunica interna. Okay. Easy things. You can tell tunica interna, tunica. Right? Yes, possible. Tunica interna. Okay. Another word is interna. Now, tunica interna is made up of squamous endothelium. Tunica media is made up of smooth muscles and elastic fibers. Tunica externa is made up of fibrous connective tissue with collagen fibers. Okay, I'll send you this PDF if you want. You can join us on Vedantu NEET English or Biology by Gopika. Both the channels you can join, and you will get this PDF there. Okay, yes, fine. Now, students, look here. You have your arteries and you have your veins. Okay, if you look here, this is called a lumen. Lumen is very, very, very large. very large in veins. Why? More blood has to flow in. In arteries, it's smaller. Why? Because here blood flows with a lot of pressure. More pressure. So in more pressure, you need a proper thicker surface, so blood vessels does not rupture. So here it is more pressure, so more muscles are here. Here the lumen is bigger. Why? Because more blood has to go. Okay, clear? Yes, 1 second. Here students, very important thing we are going to come into. I will show you with the diagram first. Students, who regulates the heart? You'll be like, what? Who regulates the heart? Obviously, brain will regulate the heart. Not actually. Heart is regulated by heart itself. That's why we have something called as pacemaker, if you have known. So students, regulation of heart happens with the help of SA node, sinoatrial node, or with the help of AV node. Okay. Then bundle of His and Purkinje fibers. So what is happening? Students, look here. In the right atrium, there is an SA node. Can you all see here? SA node is there. This SA node will actually control all other types of nodes. Okay. This SA nodes, next to that you have AV node. Where is your AV valve present between the atrium and the ventricle? So somewhere close by you will see AV node. These people are actually controlling how many heartbeats should happen, how many minutes, how much beats should happen, how many cardiac cycles should happen. Like entire regulation of your heartbeat is done by these people, right? So SA node is present on the right atrium corner, and then you have here, you have your atrioventricular valve, which is almost near to the atrioventricular valve. We have an AV valve. From the AV valve, students, there is one extension, like one tree. Okay, like a branch or a bundle, there is an extension called as bundle of His. Bundle of His. Bundle of her is not there, bundle of His is there. From this bundle of His, there is some fiber-like texture called as Purkinje fibers. What is it called as? Purkinje fibers. So these four people actually regulate the heartbeat or control the heartbeat. Got it or not? Okay? Yes? Easy? Look here properly the diagram and try to understand. So students, how does it happen? See, SA node will send direction to AV node. AV node will send direction to bundle of His. Bundle of His will send direction to Purkinje fibers. So who is actually the headmaster of the school? SA node is the headmaster of the school, also called as a pacemaker, because SA node will decide the pacemaker of the heart. Got it? Pacemaker of the heart is SA node, which regulates or which will actually control the pace of the heart, right? Pace of other people also will be done by SA node. Clear or not? This image is more than enough for you to understand. Just know the terms, okay? Just know the terms. Students, actually, AV node, your SA node can fail and people actually put, okay? Should I repeat that once again? Samim, should I repeat who controls the heartbeat? Can you please put it in the chat box? I will repeat it. You want this topic or something else to be repeated? Quickly, tell me. Do you want me to repeat SA node? Okay, let's wait for his message. Students, so what is happening? Who regulates the heart? Brain does not, like brain sends signals, I totally understand. But heart regulates itself. So who regulates in the heart? SA node, AV node, bundle of His, Purkinje fibers. These four people send signal to each other telling, I will control this, you control this, right? So SA node is the pacemaker of the heart. That means he or this SA node decides the pace of the heart. SA node will send signal to AV node. AV node will send signal to bundle of His. Bundle of His will send signal to Purkinje fibers. Okay. I think here you're not able to see Purkinje fibers, but students, it is like this. They're like proper fibers. Okay, proper fibers like this, extending and covering the entire ventricle. So this Purkinje fibers completely covers the ventricular region. Ventricular region will be completely covered, okay, with the help of Purkinje fiber. So out of all these 4 people, who is the headmaster? SA node is the headmaster. And sometimes SA node can fail and people put artificial pacemaker, because without pacemaker, control of the heart does not happen. Beating of the heart has to be controlled. Everything has to be controlled. That will be done by this. Clear or not? Yes? Yes. Okay. Now students, ECG. Almost coming to the end of the topic. ECG. Okay. 1 minute. Yes. Okay. Students, look here. Your ECG or your electrocardiogram is the way for us to, how do I say, regulate heartbeat, to check. Have you seen in movies like this? It happens when that person dies. Straight line. That means what? The heart has stopped. Right? That can be checked by your ECG. And ECG is just not to check if the person is going to die or not. It is also to check if there are any kind of conditions. Yes or no? So students, the instrument used is electrocardiograph. Okay. The instrument used is electrocardiogram, and the graph that we get, what do you tell, the graph we obtain, electrocardiograph. Got it? Now how does this happen? So imagine students, this is a person. In this person, we will be connecting this, what do you call? You actually, let me tell the scientist also, no? Yeah, I'll tell you the scientist also. So he got Nobel Peace Prize for this. Okay, he is a person who also got Nobel Prize. His name is Enthoven. Okay, is the scientist. Okay, so students, there are actually leads. Okay, this is called leads. So we will put 3 leads on this person. Okay, one here, and one on his left. Okay, left leg. Now, this is almost like a triangle, right? It is almost like a triangle. So these are the leads. So there are up to 12 leads. Right now we use a lot of leads, but for your NCRT knowledge, 3 leads are more than enough. One on the right, one on the left, and one on the left leg. Okay, right hand, left leg. Leads will be put to take the ECG. Now what happens when you take the ECG, students? I will show you. See, look here. You will get something like this. Right? You will get something like this. Now you should understand what are these waves. What is each part of the wave called as? Okay. So let's label this P, Q, R, S, T. These are the labelings of the waves. Now understand, S is the least. That means the most dipped wave is S. R is the highest. R is the peak. Okay. R is the peak. Okay. Now students, for P. Now what does P indicate? P indicate AS. What is AS? Arterial systole. P indicates arterial systole. So do you understand? Connected with cardiac cycle. The events of the cardiac cycle. So P indicates the arterial systole. P indicates atrial systole. Okay, clear or not, atrial systole? Since that happens because of a depolarization, which you will study later in your MBBS. It happens because of arterial depolarization, which is actually like a response, right? So that response will be an arterial systole. Now, if you know depolarization, repolarization, you understand, no? Change in ions will cause one change in the, one stimulation. Like that only here also. Okay, clear or not? Then students, this QRS, this whole thing, QRS will indicate what? Ventricular depolarization or your ventricular systole. Okay, this will indicate ventricular systole. So you will assume that this is the JD. No, it is not the JD. Students, this is ventricular diastole. What is it? Ventricular diastole or ventricular repolarization. Okay, it is called as ventricular repolarization. Ventricular repolarization. So this is, I will write that also here. So this is atrial depolarization. This is ventricular depolarization. This is what? Ventricular repolarization. Then you can ask me, ma'am, what about arterial repolarization? Students, arterial repolarization happens, but it does not make an impact on the ECG. That means the value has to be a little high for such a curve to happen. That curve, that value is not there. It is happening, but it is not being detected by the ECG. Got it? That is why we do not have arterial repolarization. Is this clear? Okay. So students, I told you R is the highest amplitude. S is the lowest amplitude. Okay. Yes or no? Yes, fine. Please copy this down. Yes. Done, all of you? Yes. Okay. My leg is paining because I've been standing for 3 hours. Okay. Students, there is myocardial infarction. All of you know. That is when your S, right? When your S curve. So it goes like this. So say there is P. So when S goes like this. Instead of going down, if the S goes in up, all the way up. Okay. That time myocardial infarction happens. Okay, myocardial infarction happens. If it goes down, it is myocardial ischemia, but it's okay. You don't have to know so much. Okay. Yes, got it? That is your ECG. Okay, ECG. ECG is done. Wait, let me see. Yes. So now we will understand the diseases, types of diseases. Okay. Students, understand cardio accelerator and cardio inhibitors are there. Cardio accelerators are the neural controls which actually accelerates the cardiac cycle. That is your sympathetic, adrenal gland and all these people. Then we have inhibitors, that will be what? Parasympathetic. One is sympathetic, one is parasympathetic, right? So those two people will do that. Now students, diseases. Look here, easy. See, coronary artery diseases or your CAD. What is that? It's also known as atherosclerosis. It's also known as atherosclerosis. Okay. Caused by buildup of plaque, which is caused because of settlement of any of these three. Can you see here? Can you see fat deposition here? That is when you eat a lot of meat, when you eat a lot of, things and there is a lot of fat. Okay, lot of fat here. That is when you get CAD, coronary artery diseases. That is because of the buildup of plaque, which is your calcium, fat and fibrous tissues. Now, makes the lumen of the arteries narrower. So, now what happens when blood is moving with high pressure, right? When blood is moving with high pressure, it will try to rupture the walls and go, right? It will damage the heart walls, correct? Why do we have lumen with so much thickness? So that the pressure can be So they make the lumen more narrower. Now what happened? Lot of blood wants to go. Everyone will be fighting. Imagine theater. There is only one door for the theater. 100 people are standing near the one door. Both the doors will break. Yes, both the doors will break. The seats in the entrance will break. Same way here also it will happen. Okay. Now affects the supply of blood to the heart muscles. That is the main problem. Okay. Artery has to supply the blood to the heart muscles. That will become a problem. Why? Because the lumen has reduced in size. So the more blood will try to go, but then blood will not be able to go. Right. That kind of a problem will happen. Okay. Clear or not? So initial lumen, imagine it was this much. After CAD will affect, coronary artery disease will happen. So what is going to happen? Here all this deposition of fat will happen, right? More deposition of fat will happen and it will turn your lumen smaller by full fat deposition. Okay, clear? Lumen. Now next disease, students, angina pectoris. Okay. It might sound like one Bollywood actress, but it is a heart disease. That means angina pectoris is not enough oxygen reaching the heart muscles. Okay. So lack of oxygen is there. Because of that lack of oxygen, the entire body has lack of oxygen and mainly heart muscles are getting affected by it. Okay. Now symptoms are acute chest pain. That means you feel a lighter pain and suddenly you will have a cardiac arrest, right? Like that. A small pain you will feel in the chest and then you will be like, okay, that's because oxygen is not enough. Now can occur both in men and women. It is not specific to anyone. Okay, it can happen in both. Even nowadays, age also does not matter. Now, myocardial infarction. So I told you, if the wave is like this, right, the S is going like this, it can cause, doctors can identify that it is myocardial infarction. So what is happening, students? The plaque ruptures and causes blockage. So there what was happening in CAD, plaque was getting accumulated. Here what has happened? The plaque has ruptured. That means it's a very serious condition, right? So imagine this is your artery. Here, so plaque was here. All these are plaques. Now what has happened, students? Plaque has ruptured. Plaque ruptured. Scattered all around, right? Now what is going to happen? Damage or death of cardiac muscle tissues, right? Blood will still try to flow in. When blood tries to flow in, it is going to damage all the muscles. Yes or no? That is called as myocardial infarction, which can be very fatal. There is no it's not like your heart attack, like it will come once and then you will realize that there is a blockage and then you will do a bypass surgery. That's not how it works. Myocardial infarction sometimes, most of the times, lead to direct death. Because why? Plaque has already ruptured. Blood is trying to go. Every time blood is trying to go, sometimes this person would have had a very acute pain, but then otherwise it is directly going to damage the vessels. Got it? Clear? Okay? Yes. So students, these are the three conditions. Okay? Can you see here? See here what is happening? Heart attack, plaque cracks and the blood clot blocks the artery. Okay, blocks the artery. Now look here, students, difference between your atherosclerosis and arteriosclerosis. So atherosclerosis means plaque accumulation, formation of plaque in the artery walls. Arteriosclerosis is actually thickening of the wall. See, thickening of the inner wall and central wall of the artery. So here actually lumen is getting reduced, right? Here what is happening? If the lumen is like this, see, if this is the artery wall, okay, lumen is like this, here thickening is happening. Thickening is happening, okay, thickening is happening. Got it? Yes, that is actually the difference. Arteriosclerosis. Here what is happening, students? Same, here different, look here. This is the artery. This is the lumen. In the lumen, plaque has started forming. Like this. So what is happening? Lumen is getting reduced in size, right? The plaque formation has started. Clear or not? Clear? Yes, that's all. We finished the chapter. We finished the entire chapter, okay, in almost almost we finished it in 3 hours, which is like amazing. Okay, 3 hours, you're going to get 16 marks. So quickly, okay, quickly let me know in the comments if you have watched the session. This is the first session on biotonic. Okay, so I hope you like the session and I hope you will join us. If you want to see more of my classes, do visit on come and join us on Vedantu NEET English and subscribe to our channel, where you will get all the PCB, that is your physics, chemistry and bio, where botany and zoology will be taken by separate teachers. Okay, so yes students, thank you so much for joining. See you all in the, I will not say next class, but see you all soon. Okay, we will try to finish human physiology, so that any students who are preparing for NEET and finding it difficult, not able to find a good biology class, especially in English, I think this will be helpful. Okay, so see you all. Take care. Bye.